Something is happening. I don't know what is the issue, but the screen is not sharing. What's the reason? Let me go through. Just
Uh,
hold 1 minute. Let
yeah,
me
yeah, yeah.
type
It's not
another
working.
email.
You share the PPT. I will open from my end and you can present. In that way, also, we can plan.
Yeah, that will be fine. No. Yeah.
Yes,
Yeah.
yes.
Correct. 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 Wait. I don't know. Suddenly, it is not happening. Okay. Yeah, it got shared.
Mm. Oh, still we are not able to view.
No, I sent to your mail. Please, you check your mail.
Yeah, yeah, yeah. I will check. I will check. Yeah, mail received. So I will.
Now, please tell. I am trying to share. Now it is visible.
It is loading. Yeah, yeah, yeah. It is visible now.
Visible. Okay, good.
Yes, yes.
Still, for the safety side, it should be at your end. No problem. Okay, no issue.
Okay, you open it. If it is not working well,
Yeah, yeah.
we can present from our end.
So sorry due to this
No issue, no
technical
issue, no issue.
issues. Just 10 minutes. Okay, directly I'm presenting the slide. Hope it is
Yes,
there.
yes, yes. It is
Yeah.
visible
Okay.
now. Clear.
So,
Okay.
thank you. So,
Okay, please.
good morning, all of you. So, let's proceed to the session. So, it's always my great pleasure, as I was mentioning it, to have the session or any collaboration with Dr. Bimal, as he's one of my close friend, I can say, who is greatly associated with me since last more than 4 to 5 years. So, it's always good to talk something about intelligent computing and big data. So out of all my research outcomes, I have chosen according to the theme of the FDP as this intelligent computing. Now, before I start my talk, let me tell you one good fact about this talk is normally, traditionally, we used to have some good talk about data science, data analytics, or some good concepts of machine learning, or some basic concepts of machine learning. So, few of the people we are much bothered about the techniques because normally what I used to find in no research market, people used to feel if we know some techniques, then we can publish some papers or we can do some good research or something like that. That is at one end it's true, just at the other end it is also true to solve the problem, because until or unless you are not finding the good problem to solve and the way to solve it, only single-handedly if we are running one method, for example maybe bias or k-means algorithm. And I hope the audience are basics, they already know the basics, at least last 3 days many people, other experts might talk about these basics. So I'll talk few things about the basics, as well as I'll come to the direct advanced concepts. And another thing is my focus will be somewhat two-way folded. That means the first way is about intelligent computing. The second part is all about the optimization, and combining those two, how we will solve the problem of overloading of industrial big data, right? Now people are telling big data, and these days, hope you know, from 20th century onwards, at least when COVID started, we are pretty good about no big data. But if you are still thinking that big data is a new area or where we need to work out, somewhat it is little old. I cannot say completely old, but somewhat it is fact, means completely in a shaping and good size of research. We can start talking about industrial big data. That industrial, while I'm talking, I mean to have all industry, like whether it is healthcare, whether it is no other good technical industry, or some uh, other good you can say kind of anomaly detection, or kind of security, or kind of IoT based some industrial data. Now, what are the contents of this talk while we are going to talk? So what is data? A small introduction about the data, then I'll come across the big data, then how to handle industrial big data, what are the ways, and up to this day, means the first day, second day, and third day of your learning, what you have learned, that I'm going to traverse little advanced in today's talk through intelligent computing. And the next part is no the focus will be on optimization, because I don't think none of the expert till today might talk with you about optimization, because it is one of the leading field of research where most of the research is going on in different domains. So we will somewhat discuss about the optimization. The next part will go for nature inspired optimization, next few applications, and my research findings, and what are the future challenges and aspects. Okay, so quickly let us start. Data, it is a very common buzzword. We know everything about data. Means much. If I say something good definition about data, it will be somewhat something like layman, because I don't want to much focus on data, because what we are seeing in our all around, no something like any facts or information, or if we observe somebody, or if we have some good information in the form of graphs or tables, or we are having some measurements, some quantities, or some other numbers, or alphabets. So anything which is collection of a bulky amount, or having some useful or meaningful information, we can call it as normal data. Now, once upon a time, while in computer science this data got evolved, most of the people, they didn't imagine even one day will come when we need to play with this data. We need to observe much about the quantities and qualities about data. Okay, so in that aspect, we normal human being, we used to have number of aspects about playing with data, and these days, knowingly or unknowingly, we are just from the morning to night having some number of data in our real life. You can see one normal slide what I have kept. So we normal human being, we just do, we say something, we just think, we feel, because normally we are having some no emotions, where our emotion recognition also plays one important research area. And the other part of good research area, no, which deals with data, the data in our day-to-day life, in the form of a smartwatch, or in the form of a banking service, some smart app uses, personal traits, values, some activities, some normal day-to-day life routines. So a normal human being in day-to-day life, what we do, it comes under good analysis of data. So if we are really bothered about data, then now the days are running where we need to really think about how to handle it, because handling data itself a art. most of the researcher, they used to work on data, the types of data, and what kind of data we are observing, where all those data are useful, or in some aspect we can have some kind of useful data in future. So these all become some kind of meaningful information when we really collect them, store them, and at later stage we used to feel like we are analyzing the data. See, a normal example, if we are wearing a smartwatch, in that smartwatch, we are getting our BP, we are getting some other good time information, we are getting our other, some blood glucose, some many kind of small things, what we are normally getting through our smartwatch only. But it is a single smart device which is able to give us number of data with the usage of it. Every day, if really we want to save those data, just make it a Excel set, make some number of columns, and please save 30 days data. After 30 days, you will come to know how much amount of MB data you have stored in your system. So it is a normal storage of data, a normal collection of data in our day-to-day life. Now, people used to say big data. Now, I have all these questions always in my talk, or the people or my PhD scholar, I always used to ask this question. So why people are so crazy about big data or deep learning? These two concepts, most of you will agree with me, in these days, you people are quite fascinated about these two concepts, big data and deep learning. Very few people are talking about machine learning apart from colleges like courses of AI ML, otherwise deep learning. But the question is, how much deep is, what is deep in deep learning, what is big in big data? These two questions are very important to understand. If really you will understand the threshold of those two questions, then a small research area easily you can find out. Okay. Now, if you will really ask me, there is no such formal threshold because scientific threshold doesn't exist for big data. So what is big in big data? Normally, in an industrial way, we used to say, if the data size is something called terabyte, 1 terabyte, it is supposed to be big data. Means, if the data is of size 1 TB, then we may accept that it is a big data. At the same time, you will ask me, sir, I am doing my research with some GB, like 2 GB of data. Is it not a big data? Yeah, it may be a big data. Nobody has role that they can say, no, it's not a big data. Okay. Now, the formal definition is little different from our scientific aspect. Okay. Now, if I'll ask you few examples, these are the few examples you may see where a normal Facebook per day, we all are using this Facebook, right? Or some Instagram, other social media apps, where what we do, we just share some photos, videos, some good message exchanges, or put some emojis or comments, that only, right? In that aspect, very few of you know that 500 plus terabytes of new data get ingested into Facebook every day. So just for 1 sec, you please think 500 plus TB of data per day. If only Facebook is giving this, then what about the other social media apps? That means per day, this is the ratio of data of one social app we are dealing. Then how much other kind of data we may deal with other social apps? At the same time, a single jet engine in our country is going to give 10 plus terabytes of data in 30 minutes of flight time. Just 30 minutes it is used to give 10 TB of data. One famous store like Walmart, it processes 1 million customer transaction per hour. 1 million customer transaction. Amazon, $283 billion. On average, office workers have received 110 to 120 emails per day. But normally we never think about all these. What we do is, we have facilities, we have some apps, we are fascinated about using those apps. So it is very good to use app and just utilize it and enjoy it. But at the back end, the data analyst or the data scientist, their role is pretty crucial while dealing with such kind of data. Now, possibly you all know, but it is just a small correction or revision of your data, understanding data size. If you will see the data size, I have started from bit to last the Bronto byte. Now, people know, many are talking about terabyte or zettabyte. Possibly you people know. And the last one, if you will see the Bronto byte, by 2025, we are going to have this Bronto byte kind of data. Now, if you will see the size of data starting from the bit, byte, kilobyte, megabyte, gigabyte, terabyte up to TB, these days we are having this hard drive and all these kind of devices, right? But at the same time, after terabyte, the PB petabyte, EB exabyte, ZB zettabyte, yottabyte, and the last brontobyte. So when we are going to have such kind of sizes of data, please see how we are going to have, means if you will see the number of byte forms, the last column, you will able to understand how much big the size of data is. So it is a very essential component in today's research area. We need to develop such algorithm, or we need to develop such good techniques, either sole or hybrid, so that this data can be easily handled. And especially much industry data are being generated at every hour of day. That is very important. Now, I want to tell you here one very important aspect. That aspect is, if we will talk about analysis of research, like most of the faculties, they used to do research on sentiment analysis, for example, or some image data, COVID image analysis, or X-ray image analysis, CT image scanning, or any cancer data, or any agricultural data, whatever. These all are the research areas, right? But if you will focus it in a good way, you will understand all these research areas are under the scanning of big data. Because while you are handling more than 10,000 images through a CNN network, it is nothing but you are handling a big data only. But unknowingly, we are thinking our research is deep learning or our research is cancer analysis. But the same cancer analysis is little big while it comes to the talk of healthcare industry. Okay. Now you see, what is the data growth over years? My analysis starting from 2010 to 2030. Now we are just on and around 2023, right? So if you will see, the structured data amount is very less, but 78 yottabyte of kind of data, you are finding only what? Unstructured data. Now, it is very important to understand how to deal with such huge or bulky amount of unstructured data. Because if the data is structured, somewhat we can use it. If the data is unstructured, first our task is to make it structured, then we will use it, right? A simple, see, most of my slides I used to keep very simplistic way so that a layman can easily able to understand, and those faculties who till now not started your research, still you can start from the area what you need to understand from the very basics. Okay, so keeping view in that, I have designed the slides in that way so that you need to realize where exactly the research domain relies. Because normally while we are talking about research or PhD, our guide will tell, this is the area, you just go develop one deep learning algorithm, apply, take one data set, apply it on one method and get some result, publish one paper. But you will actually come to know what I am doing when you will realize the fact. Okay, now, so if you will talk about the top big data applications, you will find it everywhere, not a single, means one or two places. You will find here, like travel, education, telecommunication, e-commerce, retail, finance, healthcare, all security industries, the software industries, everywhere you will find it in a common way. That's called big data. The only difference is naming conventions are different, nothing more than that. Okay, now what are the big data types? Now, I am having a slide which talks about three kind of data. One is structured, one is semi-structured, one is unstructured. So normally in our real life data, if we want to no, make it divide the data, what we are observing in our day-to-day life, you will find only these three kind of data. One is structured, unstructured, and semi-structured. See, while I'm talking about structured data, you will see some small diagrams of this Excel sheets, IBM database sheet, this Oracle DBMS, and other some good text files and others. Okay. If you will talk about the unstructured, you may find all the social media apps. Hope you can see the chatbots, the YouTube. Sorry. So while we are talking about semi-structured data, neither it is structured, neither it is unstructured, but those are not exactly ready for analysis, but we can make them analyze for a smaller applications. Okay. Now, let me brief you little about the type of data. Now, let me tell you one very important thing. The kind of data scientist or data analyst, now what we are doing is most of the courses are coming all as data science or data analytics or AI/ML, like artificial intelligence and machine learning, or else data science. These courses are running. But in these courses, the most similar topic what you will find in both areas is data, big data, analyzing data, machine learning. These four things you will definitely find in both the courses, only of difference of different type of methods, nothing more than that. So in both the cases, it is very important to understand what are the kind of data. See, a small example I have given you, a structured data, a kind of normal tabular format in the form of attributes and the domain names. You may find here the column names like employee ID, employee name, gender, the department, the salary, and all the columns of respective fields. Now, this is very structured because its corresponding field name consists of its exactly the data or the information it is holding, right? Now, coming to the second one, which is unstructured, a simple task, you please write your name in the Google. That's enough. So what I am showing you is triple IT. Okay. So if I'm showing triple IT, Google will tell you number of triple ITs, even some IITs, because the filter on or the exact information, and these days this unstructured data is being little bit structured through this chatbot, right? These days we all are fascinated about this chat GPT, no? So this is one of the famous search engine these days which is coming as a structured way, right? Because people used to admit that Google is not a structured search engine, it's an unstructured search engine, right? So the unstructured data in the screen, you can see it will give you numbers, the figures, some directions, the website links, many things. These all are data, because if I'll have 100 number of website link, that is also one kind of data, right? So it is important to understand the kind of data we are getting in an unstructured way. If it is unstructured, now our first task in this screen is please make them distinguish among the images, among the different fields, among the different other numbers. So number will be one structured data. The website link is another structured data. Now the image is another structured data, right? So out of one unstructured data, we can find number of other structured data. Now, the same case, little different, you will find in case of what is semi-structured data. The best example of semi-structured is one XML file. Because in XML, what we used to do is, normally we are writing one command, then the field name, then the end of the command, right? Means it used to take the form, but it is not storing the data. The data can be, means the same semi-structured data, we can find it with some definition in an Excel sheet. Now, when we are writing it in an Excel sheet, it becomes structured, right? So these are three basic distinguishing of data, what we are observing in our real day or day-to-day life scenario, right? So what is our task? Our task is very simple. Please combine them all the unstructured data what you are finding on the left hand side of my screen. Means you can see the pointer. I'm using the pointer. Wait, can you see the red pointer I'm using? Hope you can see it. Is it visible? Hello, am I audible?
Yeah, yeah, we can hear you.
Yeah. Okay. Okay.
Mm.
So if we'll go for this is the kind of what the complete complex structure of data. So the task of a normal data scientist is very, very simple, to make all this kind of unstructured data into its corresponding simple structured data. So this is the basic of any good research in data science or data analytics based research in computer science. But we never realize about that. What we do is we take one data set, we do some method, and with some result, we used to feel happy that my research is complete. But normally it used to never happen in that way. Okay. Now, please let us come. So how to make decisions from this big data? It is important to have the decision from this big data in the form of analytics. That analytics itself, in that you need to analyze the data through different methods. Those methods used to come under intelligent computing. That means whether you are talking about machine learning, deep learning, artificial intelligence, computational intelligence, soft computing, these all are interrelated disciplines where number of methods we used to find, and those methods we are using, right? Now, big data are supposed to analyze to get some good, correct decisions. Okay. Now, I will talk to my second part of the talk. Again, I'll come back to big data, because what where I kept in the last slide, please see it. See, all the slides are pretty interlinked. Please listen these slides very carefully, so that you will find at least 2 to 3 research area up to the end of the slide. Okay. Now, in this slide, what I told you is we are finding the big data, and we need to analyze those through some methods. Those methods are coming under different sections, like soft computing, machine learning, AI, deep learning, all those methods what you are seeing in your computer science domain, right? At the end, what is your task? Please take some decisions or having some decisive statements regarding the data. Okay. Now, in that means out of those means many analytics method, one very important aspect is optimization, because people used to feel my machine learning method is ready, my technique is ready, I can able to develop the technique. These days, with the help of Python and MATLAB, I don't think many people are developing the method, rather they're using the method. Because you all of us means who have used Python, you people will agree with me, what we do is in the Python already the inbuilt library are existing. We need to use the files or the library commands. Those commands used to tell us what are the schematic diagrams of or schematic methods or processes of the methods what we are going to use, and just apply the method, get some result. But it is also true, while you are talking about big data, your normal one single hand method may not able to realize or may not able to give that aspect of output what we are able to imagine. We used to feel one KNN method, one neural network method, or one back propagation neural network method is sufficient for all kind of data. But the fact is not at all that true. We all know one very famous no dataset repository, that is UCI machine learning repository. Hope all of you know that is University of California machine learning repository, where early days before 10 years people used to take the datasets from that. Okay, these days people are very good to take the datasets from sources like this no different kind of IEEE or other good sources of no data sets, where normal even in the website links or normal Google also people used to find some good kind of data. Now the fact is, early days what used to happen, people used to take one iris data. Hope everybody knows one iris data, IRIS. It is one of the famous data set having 3 kind of class, Setosa, versicolor and virginica. So people used to do what, take the data, implement through some basic machine learning method like no backpropagation algorithm or multi-layer perceptron like MLP, and get some result. But what happens day by day with the growth of data, when such kind of traditional method are unable to handle such big data, now the task arises where a single method may not able to handle such kind of data. So we need to revise the method. We need to revise the method in the form of adding some layers, that is deep learning. Means while we are constructing number of layers by layers by layers, so at the end we are finding it's no, it's a deep learning, right? Or the second way, or the very best way to handle or to tune those deep learning techniques, or including the machine learning technique, is optimization. Because optimization helps you to get that result to be optimized in all the sense, starting from machine learning to deep learning. Not only machine learning, not only deep learning, including the both. Okay, I'll tell you some nice interesting algorithms or methods where we can find our new research area. We can really do some good work. Okay, so if you will talk about optimization, it is nothing but selecting some best elements from the set of available alternatives. Because in our day-to-day life, we used to optimize a number of results. In our Indian market scenario, while we are going to purchase a normal vegetable, if yesterday we came to know the potato rate is 10 rupees, today he is telling 11 rupees, we used to find, what do you know, I'll take 2 kg, give me on 20 rupees. So what I am trying to find is, if 1 kg potato rate is 11 rupees, I will tell him that I want to take 2 kg, so that 2 rupees you reduce in 2 kg, means per kg again 1 rupee is going to reduce, where I am going to get yesterday price. Okay, this is what one form of optimization, where you find 3 values. One value 1 kg 10 rupee, second value 1 kg 11 rupee, third value 2 kg 20 rupees. Okay, so optimization is just finding some basic good best elements with some criteria. Now here, what is the criteria? My criteria is I need to increase my amount. If I'm increasing my amount, definitely I'm having some good kind of concession from the shopkeeper. Okay, so an after decision is fully perfect, functional or effective as P process or methodology of making something a design system possible. So what is this? If we are going to talk about any functional or fully perfect design aspect of a system, then definitely we need to make it optimize. And in optimization, you will find only two kind of problem. The first one, maximization. Second one, minimization. Okay. See, here one point I want to add, because this is a FDP and all you people I am supposed to fact means feel it's either research scholar or the faculties. In during BTech, you may find in most of the BTech curriculum, you will find at least one numerical computing or discrete mathematics will be there. This subject, what is the need of that subject? Most of the time we used to feel what to do with numerical computing or this discrete mathematics. In that, definitely one chapter you will find the chapter of optimization. The reason behind that is, in future, if you want to grow methodologically as a computer scientist, definitely you need to learn how to optimize a basic method, how to optimize a basic line of work where my work can be more efficient. Now, according to optimization community, there are two kind of problem. One is maximization, one is minimization. Because either you need to maximize the quantity or you need to minimize the price. Then only you are able to find the real solution in between that. Okay. Now you need to compute the value of the function while choosing some best input values given from the allowed set. That means out of number of given set values, you need to choose the best input values to maximize or minimize the function, so that you are feeling my function is going to optimize. Okay. Now, this is the case in most of the solution or algorithm. We used to find either the maximum or minimum of a smooth function. Hope you know what is smooth function. It normally used to reach on a stationary point when the gradient used to vanish. That means the down or the up, you can find the means maximum value over here. This is my maximum value of this gradient, and this is my minimum value. Now out of this, if all around either you are finding a value in between all this, then you can easily tell this is my good optimized value. Either your inclination towards maximum or your inclination towards minimum. Okay, this is a basic problem or basic mathematical function derivative. Now, if we will talk about optimization, you will find it everywhere. None of such cases is not there where you will not find optimization. Okay, means the personal decision making processes where I need to find some faster route from my home, because while no, by looking into the petrol price, every day our task is very simple. We used to see what is the shortest route from my home to my institute. So I'll go by that. That finding shortest or fastest route, that itself a problem of optimization. Okay, means we do optimization, we really feel optimization every day, we really talk about optimization, but we never realize, oh, this is the problem of optimization. That we never realize. Now optimal budgeting, like our home budget of every month, optimal allocation of time for homework or something like that. Okay, now, what is the goal of optimization? If you really find what is the goal of a normal optimization, finding some good values of variables that minimize or maximize the objective function. I told you, but satisfying some constraint is important, because in AI, you might have gone through the constraint satisfaction search, where you need to come across through certain constraint to solve a function, right? So if you are able to find some good number of variable which used to either maximize or minimize the objective function. What is the objective function? The function upon which we need to work. Okay, so if our satisfying constraint is okay with the function and we are able to minimize or maximize it, then definitely the goal of my optimization is going to reach. And you need to make some good analysis on how to get the best result when approximating some solutions of complex engineering problem, because most of the complex problem, either in the form of maximization or minimization, we are not able to find the real path among balance of in between those two, and those balance is very important. Means whether you are able to find the solution at local end or at global end. Okay, I hope in AI another topic you might have gone through, that is a hill climbing search. One algorithm is there, it's called hill climbing algorithm, right, where it used to take the help of backtracking method to climb the hill, and how suitably the user can go and climb the hill. At the same time, it is always very important to realize what is the exact balance in between the exploration and exploitation. Now, the question simple: what is exploitation? What is exploration? These two are the most important concept while you are reading optimization, because any such good evolutionary algorithm which is nature inspired or which is technology based means technique wise, we need to talk that my exploring good algorithm or good technique, it used to give me number of certain aspect. Then I need to say, you need to understand what is exploration, what is exploitation. Now you see, the other name of exploration is diversification, or simple word, global search. Okay, we know what is global search, right? Now the second one, exploitation, it's nothing but intensification. And the other word of exploitation is intensification. Now intensification is nothing but more local search. Okay, now if we are talking about diversification, it nothing but it simply denotes the process of discovering the diverse solutions within the search space. Means out of all randomized solutions or random solutions, how you are going to explore your global search capabilities. That means, please see my screen properly. If I'm having a hill climbing algorithm in this way, I hope my pointer is visible to you, right? Can anyone please answer? Is it visible to you?
Yeah, we can see that.
So you can please see, if I'm going to talk about this gradient, now where exactly you are able to find out how I'm going to explore the global search. Now, if really I am finding my solution under some of the vicinity of here, that means either at this point or this point or at this point or at this point. So some point of time, I will definitely find out of some of the random solutions how I am going to reach the global best search. But locally, if I'm able to find the search among this to this or this to this, now definitely it is all under intensification. Means your more focus is you need to go for the vicinities of best solution in a local way. Hope it is clear, these two concepts. What is exploration? What is exploitation? But a good optimization algorithm always talks about balancing these two. If you are not able to balance the exact measure in between exploration and exploitation, then you may find more number of error, or the rate of error will increase in case of your algorithm. Hope it is completely clear. Okay. So what is the task? Whenever you are going to develop any such machine learning or artificial intelligence based algorithm, please keep in mind, I need to develop the algorithm in such a way, I need to make the solution in an optimized way, either with the either or else with the maintaining balance of exploitation and exploration, both. Okay, trust me,
Sir,
you
good
will.
morning. Sir,
Sorry, any disturbance?
sir,
Yeah,
I
please.
have a doubt, doubt, sir. So just now you took an example of a hill climbing and you said that you are searching for the maximum value over there. But
Yeah,
assume that the first hill is a smaller one compared to the next one, then it
yeah,
won't go for a globalization over there, sir. Global optimization will not be done over there. Means according
correct.
to the hill climbing algorithm. Then
Yes.
how this example will be the best example for this exploration and exploitation, sir?
No, 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 no. Hill climbing is not the best example of exploration and exploitation. Hill climbing is one of the algorithm of local search. You may find the limitations of hill climbing. That's why the no RISI and local search and local maxima. So what I want to say you is hill climbing is one of such algorithm where we need to search one of those search space where locally we can find the solution. It's not about hill climbing is the best solution for both exploration and exploitation. Got it?
Okay, sir. Thank you,
Yeah.
sir. Thank you, sir.
Okay. So what exactly we need to do for optimization? Now, the model, what we are going to develop, the algorithm, what we are going to talk. Okay. Now the model is nothing but process of identifying some good objective function and the variable and constant, where the goal is nothing but inside finding some good numbers or having some good mathematical model of optimization problem. Now, if we are going to talk about modeling such algorithm, then we are going to find some interesting model which is too much complicated and can be able to solve with a piece of paper and pencil. Now, it is an effective and reliable numerical algorithm is always needed to solve the problem. And as per the no freelance algorithm or the concept, we know there is no such universal best optimization algorithm which can solve all the problem. But always there is a solution, means our goal is to find such a good solution to reach over the nearby solution of that algorithm. Now, we know some traditional algorithm. If we will talk about good traditional algorithm or classical algorithm, the first concept we will come across genetic algorithm, because it is one of the oldest algorithm. Now, from genetic algorithm, which is under one of the evolutionary category, there people used to feel after genetic PSO came, which is particle swarm optimization, and this year, no, particle swarm optimization covered almost 25 years. Now, out of those no algorithm, many such good problems have been solved. That's true. Also, it is very important to find out what are the basic limitations of all such traditional optimization algorithm, where we are working on some good optimization techniques in these days. If you will see the optimization community or the researcher, most of the optimization algorithm are based on nature. Now, what are exactly the classical problems or limitations of those techniques, so that these days other good techniques are being developed? And if you will come across Indian researcher, few of our Indian researchers also developed few optimization algorithm rather than all the foreigners. Okay. Now, basic some good limitations of all those algorithm is, if you are going to talk about the constant, means how to handle the constant, one of the best example of penalty method. Now, second is, most of the algorithm is going to talk about stacking at local optima. Now, always we are not going to maintain the exploitation or intensification kind of problem. We cannot develop such algorithm which is always stacking at local optima and which is not going to talk about some good searching capability at global perspective. That is one of the basic disadvantages. And most of earlier developed optimization algorithm, they used to talk about derivatives of objective function and constant. Now, when you are going to talk about any optimization, definitely you are going to talk of objective function and constant. But how far the number of constant are going to reduce, that is one big aspect. The second aspect is the objective function, or how you are going to derive the objective function so that the number of parameters will be very less. So most of the algorithm in these days of 20th century, like teaching learning based optimization, TLBO, and other good some algorithm which are based on some insects or some natural elements, they used to talk about, no, these optimization algorithms are very far away from hyper tuning the parameters, or I am having less number of parameters than other classical algorithms. So that's the reason more number of algorithms which are nature inspired these days coming to market. So what is a nature inspired computing or nature inspired algorithm? When we are going to talk, when we are going to investigate the model or the computational technique which are inspired by the nature, right? Now we need to attempt such good concept which are there all around information, and those all around information which are just surviving with us. Means we all are living in the nature, where we need to connect most of the computer science algorithms or techniques with some natural sciences. Now, these are a very famous developing concept with adding some good elements or source of inspiration from nature. Now, if you will talk about the best inspiration of nature, it is nothing but about human, right? From the beginning of the day one of human civilization, we used to take one by one, this kind of monkey. We used to tell a small reflection of a human you can find in the form of monkey. But through the civilization grows, or when we used to find the most good intelligent human being in this planet, is all about transformation of human. There we used to find most of the nature as inspiration, as well as nature used to behave as an implementation substrate, because in nature everywhere we used to find the source of inspiration in a different kind of form of computation. The only relevance is how you are going to relieve, means finding some good or information or extracting those information, transforming those information into your mathematical model. Then only all those models you can easily talk about what the nature inspired models or nature inspired computing. Okay. Now, if I'll talk little more about nature as an inspiration, in all kind of our computer scientists, you will find all these areas like cellular automata. It is nothing but the inspiration from self-reproduction. Neural computation, which we are going to talk about neural network, it's all about evolution of brain. Now evolutionary computation, it's all about evolution. Swarm intelligence, it's a group behavior or swarm behavior or swarm elements which we are finding in the form of ant, cat, fish, or all those elements which are having the behavior of groupism. Okay. The next one is immunocomputing, which is one of the immunosystem behavior study. Artificial life, it's the properties of life, because artificial life sustainable algorithms are also existing as nature inspired optimization algorithm. Now membrane computing, it is one of the evolving area these days in 20th century. It's all about cells and membranes. And the last one, amorphous computing, which is morphogenesis study. Now if you see, we are little more focusing about the left hand side blue color content like cellular automata, neural computation, evolutionary computation, and etc. But how we are going to correlate all these areas to the right hand side, that is reproduction or brain or evolution. So if closely we will visualize all these computer science topics, these all came from nature, which is one of the biggest source of inspiration for developing also all such good algorithms. Okay. Now it's all about 20th century talking of our, I can say not talking, it's all about saturation of development of nature inspired optimization algorithm. Because these days, if we are going to talk about physical based or chemical based or any animal based algorithm, at the same point, you are going to talk about all these are categorized as one of the good source, main original source of nature inspired optimization algorithm, where you will find the black hole algorithm, the other immuno-based algorithm, the small insects, the firefly, no, and the behavior of fireflies, suckling frog, many such, means any such element in the nature which is not there these days. People are not developing such algorithm. So what and how it is being inspired to them so that they are able to develop such good algorithm in these days. See, properly if you will visualize, it's all about groupism behavior, swarm behavior, or taking the behavioral elements from one nest to another nest, or taking number of elements starting from one aspect to another aspect, how those all elements are behaved, just to study those behaviors and modeling those behaviors into mathematical computation. It becomes nature inspired optimization algorithm. But don't forget one point, all those algorithms, again, it is dependent on the size of the problem what you are going to solve. It depends on the kind of both maximization and minimization problem. At the same time, it is very important to understand the kind of categorization of those algorithms. See, very neatly I have given you the kind of algorithm what we are able to find. So basically, this is the broad categorization of optimization. If I talk about optimization, starting from the left to right, the broad categorization is of two. One is exact, one is approximate method, right? In exact, you will find the constant satisfaction, constant programming, or this branch and bound, this dynamic A star and all other algorithm. Coming to approximate solution, you will definitely find the heuristic algorithms and the kind of approximation algorithm where approximation theory comes into existence. Coming to branch index, there you again find the branch and bound, branch cut, branch price, and remaining algorithm. Coming to heuristic, again there is a difference in between meta heuristic and the problem specific heuristic, where in meta heuristic means most of the nature inspired optimization algorithm people used to talk about, it's all about meta heuristic. There the broad categorization of nature inspired optimization is evolutionary, swarm, chemical, and physics, right? You may find number of research papers in either of these four, of evolutionary, swarm, chemical, and physical based algorithm. But let us come to know some other good concepts which are means those technologies are also being taken as a source of inspiration of nature. Aircraft wing design, how many of you know it is nothing but one of the good inspiration from the bird albatross. At the same time, the next is wind turbine design, where most of the mechanical engineers used to work. It is nothing but a small inspiration from well, the fish well. We used to take the inspiration to design one good wind turbine design methodology. At the same time, if we are going to talk about bionic car, it is nothing but the inspiration from box space. Now you see how technology is directly transforming from the small source of informations of nature into technology. That means most of us should aware about the kind of inspiration we are really getting from the nature to develop the next level of technological advancements. Okay. This is another example. If you will find the bullet train these days in India, we are no, the Modi government is also talking about bullet train. In fact, few bullet trains I hope they have started. Now the bullet train is nothing but it's a nose like kingfisher, big. No, it is one of the very good concept of nature. See, all those high profile technological aspects, this all comes under as one of the good inspiration from nature itself. Now, when I'm going to talk about optimization, definitely I'm going to talk about intelligent computing methods, because my task is to handle data or in the form of big data with the help of technique. The technique is nothing but one of the method of this intelligent computing, where those computing methods are supposed to get optimized by the efficient optimization algorithm. Now, after completion of those optimization concept, if you will talk about the intelligent computing methods, you please see this is just a broad categorization of artificial intelligence, because most of the time people used to find like early days or from the ancient days, we know this artificial intelligent machines or von Neumann machines, where this you may find some von Neumann or some good scientists like Alan Turing, who used to develop some good algorithmic concepts in AI. Okay, while we used to talk about AI, it is very important to understand like the categorization of development or the saturation of AI, where it comes, or the periphery of AI, up to which time it leads. It leads up to machine learning or this big data, deep learning or the data science. This all under a simple small periphery of AI. Okay, means while somebody is talking, I'm doing research in deep learning or machine learning, he's not at all far away from AI. It's all about talking AI, whether developing an intelligent algorithm or development of a small car, or developing a driverless car, where people used to talk there is no driver, how the car is running. It's all about AI smart car. That AI smart car, again, it is the technological advancement of many intelligent algorithms. Okay, so machine learning, deep learning, these all are just kind of subset of AI, where this is the kind of categorization, if you will see, starting from AI to deep learning, and the engineering of making intelligent machines and programs is all about AI, where you are going to talk the next generation of 20th century, that is machine learning. It's all about ability to learn without being explicitly programmed, because in machine learning we are only able to see the outside structure of the algorithm, how it looks, how it behaves. Rather, we are not at all interested to know how exactly it is being tuned or it is being designed internally, so that the algorithm is behaving like that, because we are really fascinating towards the applications of ML. Most of the applications of AI is related to both ML and DL. Now, while the advancement of this machine learning to deep learning comes to picture, there again you will find the learning based deep learning neural network. Okay. Now, the era, if you will see, starting from 1950s to 1970s, late 1970s or 80s, it used to be dominant area of AI. Now, from 1980s to 2006-7, almost you will find the dominance of ML. But here the slide doesn't end. Don't think up to 2023 now we are still the deep learning is dominating. Rather, deep learning is saturating. Because if you will see, closely see the analytical aspect, I don't know as a user perspective how you used to feel, but as a researcher perspective, I always used to feel in a different area of theme how many years a technology is going to dominate. Means almost 15 to 20 years of saturation, a new technology is going to come based on some of the subsets of earlier technology, right? The basic deep learning, where we started before COVID or it was something like that, everywhere the buzzword was deep learning. Everybody was talking about CNN, this recurrent neural network, or some other good deep learning methods. But at the same time, how much people are going to talk and how many days people are going to talk about deep learning, that is one good important aspect to the next level scenario. So what is the early days scenario of handling big data? If we are going to talk about the old days scenario of big data, there are many kind of this learning. Means either we are having in the concept of machine learning of supervised way, unsupervised way, reinforcement learning, where most of the people they used to have some good applications of both supervised and unsupervised. Other than talking about supervised and unsupervised, people are more fascinated to talk about classification, clustering, prediction, regression, or such kind of forecasting, these kind of applications. So it is very important to understand the kind of learning technique we are going to use in our problem based on the kind of problem we are going to solve. Now, here in my slide, you may see there are a number of research areas, how and where we are going to talk about the areas like meaningful compression of an image, big data visualization, structure recovery, the feature elicitation, recommended system. It is another application, good application. You can go for the pattern recognition, customer segmentation, real-time decision. The game AI means developing some good artificial intelligence based games, customer retention, the diagnostic, image classification, forecasting, prediction, process optimization, new insights, many such good applications of robotics, skill acquisition, finding the good profile, image analysis, Twitter analysis, text processing, crime analysis. There are multiple applications. Question is, all those applications are holding similar kind of data or dissimilar different categorization of data. Now, before you are going to decide your method, most of the researchers what they do is first they used to take one machine learning method. Suppose the method is MLP, multi-layer perceptron, or back propagation algorithm, or SVM, support vector machine. Okay, just take SVM. Then you find what is the problem need to solve with SVM. That is one of the good mistake everybody used to do. It should be just in a reverse way. Your problem should be with you first. What is your problem? According to the problem, which method is going to be suitable for the problem, you need to decide that. Then you please learn the method. Then you find out what are the advancements of those methods over those problems. Then you can able to find the real solution for that problem. Rather, arbitrarily just take one problem, implement one method, and try to find out some solution. That's not the way to do a healthy, good practice of research. Now, why to think little beyond about ML? Because most of the time people have thought about little above ML. Because once upon a time, machine learning researchers used to feel they may not find no a good technique of ML over that, or ML is going to be dominant for next 40 to 50 years. But it didn't happen like that. Though deep learning is another superset of machine learning, but at the same time, you cannot say one of the good way of finding in this present days data scenario, machine learning itself is enough. Sorry. So please you see, what is the gap? There is a big gap in between this line, the down line, and this line. So what you are able to find, this is the available data these days. Okay. What the kind of data you are finding early days is just all around this line. So it indicates what the data volume is going to explore in a different way. That means the size and volume of data is growing in such a way we cannot think about only some good basic traditional methods of machine learning which will deal those methods. More than 16 million text messages are sent every minute. Okay, see some interesting data size. More than 100 million spam emails are sent every minute. 100 millions of spam emails. Where those emails will go and where those emails are going to capture and store the data. Every minute there are more than a million Tinder swipes. At the same time, every day more than 1 billion of photos are uploaded in Google Photos. Neither in Google, it's all about all social medias. So data is voluminous, data is growing, it is exploring in an exponential way, day-wise, weekly, monthly, yearly. Our task is to develop such good methods to handle all these complex scenario of data or voluminous data. Now, if you will see the interrelationship of beyond thinking in between machine learning and deep learning, how you can correlate the big data with deep learning in a deeper sense. Now, in big data, we used to find these normal features like velocity, volume, variability, value, veracity, and variety. These are some good characteristics of 5 B's of this big data. At the same time, why deep learning is little more top over than machine learning to find all these good learning methods in different kind of aspect scenario. See, in deep learning, you are able to find multiple layers of abstraction, training benefit from larger data set, while it was not able to find the same kind of training benefit or training capacity in the case of machine learning applications, where you can automatically extract the features, you can extract some complex patterns, you can extract some good heterogeneous data, and you can also handle them in a good structured way. The advantage of deep learning is not just about adding different deeper layers or number of layers. Rather, the handling of layers and calculating each layer starting from the input to the output is much pretty easier, and the kind of function and objective we used to find through deep learning is a little marginally better to handle such complex variety of data. Now, why these days deep learning is so popular? The reason is simple. First thing, small and medium-sized companies, they are little far away from the kind of handling amount of data through machine learning. Second, the industry giants, they all talks about deep learning because they don't have the provision to handle such large amount of data with some of the quality gaps of AI. Okay, that means the kind of amount of data is increasing, the same kind of voluminous methodology in learning technology using deep learning is also increasing. So when our technology giants, they used to deal with such good technique of deep learning, definitely they are going to talk about some of the good new advancement of algorithm rather than some older algorithm. Now, this is a simple, very simple scenario to differentiate among deep learning and machine learning. They are a basic layer you will find, which is one of the second layer, the feature extraction. But you know, there are many such feature extraction algorithm starting from, you know, such good early days PCA or many, there are 100 number of algorithms of feature extraction. But at the same time, bundle of features while you are going to handle, deep learning is able to both handle those features as well as it is able to classify using the method. So these both, if you will find the real difference, one direct layer of feature extraction is reduced is machine learning. So my basic aim to keep in between the differentiating component among machine learning and deep learning is you just handle one input. To that, first extracting important feature from that input itself takes lot of amount of knowledge. Okay, it is not that much easy to extract the kind of feature you are going to extract from the input. Then from once your feature is extracted, next you are going to classify or you are going to talk whether it is car or whether it is donkey or cat or something like that according to your classification criteria. If you will go to talk about deep learning, here the concept is little different in the sense the feature extraction is going to be added along with the classification. Means by default, the deep learning algorithms or the methods able to extract the feature, read the important feature out of number of features, then they are able to classify them whether the output is coming to according to the criteria of classification or not. So it's a basic definition of data and all other intelligent solutions. We need to be pretty cautious and accurate to find what the level of data or amount of label data we are going to use and what is going to be the real performance of the model. If you will see the kind of deep learning neural network, smaller neural network, and conventional machine learning. These are the three basic methods of intelligent computing where the human level performance you are almost able to find in the form of where? Here, deep learning neural network. But at the same time, I want to tell you here one thing. The deep learning method may be in some of the applications of image or other recognition capability, it might reach up to the level of 95-96% of accuracy. But at the same time, it still need to be fine-tuned to exactly perform 100% of model performance in all kind of problems. So it requires that much amount of time still to handle all those complex data in future aspect. Okay. So in between all this, what we are going to do in industrial scenario, the new era is going to talk about the big data or generation of big data through many IoT devices. And if you will see IoT, I don't want to say IoT or something very big statement about IoT. The reason these days, even in the TV advertisements, we are able to find the Philips bulb advertisement, which is one of the good application of IoT. Okay. So all these smart term, whenever we are going to talk, smart watches, smart buses, smart healthcare, smart fashion or smart clothing, smart city, all these applications are coming under this IoT. IoT is going to generate number of bulky amount of data. See how these all technological concepts are interrelated, and most of us we never realize exactly which domain I'm doing the research, what kind of research outcome I'm finding. It is exactly within what is the domain, means what is the exact domain, the research kind of thing I'm doing. The big data, the generation of data is nothing but you are going to find almost all around from IoT sensors. There are number of sensors around us we can find in our day-to-day life. That's why the basic term, apart from telling Internet of Energy, IoE, Internet of Medical of Things, IoMT, Internet of Vehicles, IoV, Internet of Military Things, that is IoMT, Infrastructure Internet of Things, Industrial Internet of Things, Commercial, Consumer, these all. At the end, you can directly say Internet of Everything, because out of all these application, you can easily find that any such application is not there where I'm not finding this IoT. Okay. Now, when IoT or its technology is completely dominant over all such traditional small appliances, then it is a basic tendency to have such kind of generation of data through all this industry. In this slide, you can see, you can find there is an industry of energy, means electrical utility, the industry of healthcare, the industry of vehicle manufacturing industry, or infrastructural industry, or normal industrial big data, or commercial industry. Okay, these all are industrial generation of data. Means these all level of IoT sensors are responsible for generating bulky amount of industrial data. Now, what is our task? Our simple task is to please handle them in such a way we are able to develop such good solution. So how you are going to handle such industrial big data? It's all about the revolutionary concepts of industry of from 1.0 to 4.0, 5.0. So 1.0 is all about 18th century, where people used to talk about the mechanics, steam and water power. 19th century, it's all about mass production, assembly lines, electricity. 20th, it's all about automation, computers, electronics, IT. Today, we are going to talk this all IoT, cloud, big data, cyber physical system. See, when we are going to talk industry 4.0, how many of you know, means you can just imagine, okay, industry 4.0 means somewhat it is related to, might be mechanical or civil or electrical, but how far it is related to computer science? Is it only dealing computer science concepts like IoT, cloud, big data and cyber physical system through industry 4.0? No, the answer is completely wrong. See, it is all about finding interdisciplinary research in industry 4.0 with such intelligent methods of IoT, cloud or big data or cyber physical system or any other artificial intelligence based concepts. Okay, so finding solutions to these days problem with all these industrial aspect and understanding the real problem in all this industrial concept is itself a big achievement in the form of research. Okay. Now, before I'll going to talk about a specific method, what you can use for handling big data, before that, I want to give you those who are doing active research in such area of machine learning, deep learning or big data or cyber physical system or normal security based system, recommended system. You can take note of all these data sets. These all data sets already, all of my research team, they have developed a number of good research papers we have published, and those research papers are being recognized by good number of researchers throughout the globe. Now, see, early days, one normal data set is there, this 𝐾𝐞𝐸99 data set. It is very old data set. So these days, if you will find, see the left side, the dataset column, you will find the names of all these data set. These all are industrial security based data, where there are number of categories of attacks you can find. This DOS attack, R2L, U2R, probing, DOS Hulk, port scan. What I want to tell you is the last two columns, please see. The second column talking about the features, where early days traditional data sets were talking about maximum 10 features. These days, any good researchers of deep learning, if you will take any feature, means any good data set from Kaggle or IEEE port, or any other source of data or real life synthetic data, you will definitely able to find how the data size is going to be big, because the number of features and the number of instances you are going to find in bulky way. At that time, by seeing a such huge amount of data, we are not at all able to understand how can I handle this data with my method. I am inputting such data, my method is able to give me just 50 to 60% of accuracy, where I don't know how I am exactly working over that. Okay, so here you can see the number of kind of instances is almost all around more than lakhs. When you will find 94,020 kind of instances of a data set, there you can imagine how many data instances are there to analyze how far your network is going to be steady to develop such kind of algorithm or not. This is one of the new data. You can find this TON IoT, bot IoT, DOS to DOS, the CSE. This all you may find some lakhs of instances, more than 72 means the first and second and third. The last one also you may find. In almost all the cases, people used to do like, if the data size is such huge, then how my traditional machine learning algorithm is going to work? It may not. Even some good deep learning algorithm may not. So there, the concept of developing the algorithm by understanding the laying of data is important. Okay. What I want to suggest you all people is, please take into measure first the kind of data, whether you are able to process those data in a good way or not. Then you go for the methodological aspect. Okay, this is the kind of data I'm going to handle. In this way, my methodology can help to my data. Then you can able to understand, yes, my data is perfect, my methodology may be perfect. These both can rely on each other, so that will definitely perform on a data. Okay. Now, beginning I told you, I'm going to tell you about how to handle the industrial data. It is one of the industrial security data I'm going to talk about. That is all about Internet of Medical Things, means out of IoV, industrial IoT, healthcare. I have just taken a small instance of Internet of Medical Things, which may inspire you to do research in this area as well as the other research areas of big data and IoT, to handle through any of the technique of AI or machine learning. Okay. Now, please let me tell you what is this Internet of Medical Things. Early days, we are very good with medical concepts of healthcare, of traditional practices. We'll go to hospital, we'll wait for the doctor. The doctor will come. They may give us some medicines or injections, and we may have some kind of connected infrastructure of medical devices. These days, not those days. See, what is the difference of those days to these days? The better visualization you can have during this COVID. Most of the time in COVID, if your disease is not that much severe, people, government also suggested, please don't visit to any hospital to spread the COVID among each other. So, how to get the medical service at your doorstep? Government and remaining all the officials, they are pretty bothered about how exactly we can find the kind of infrastructure or good medical healthcare infrastructure at my doorstep. So IoT is such a good area where it is almost all around talkative structure of connected infrastructure of different medical devices, including the software applications and health system and services. See, our earlier healthcare system was there, hospitals were there, doctors also there. I'm not going to replace any doctor, neither the hospital. The doctor is there and the hospital is there. Just make the services of doctor and hospital everything on the device of online. Okay, so the best example you can find, it's almost all around taking advice of telepathy or telemedicine, right? These days, people are pretty good about taking some good suggestions or advices from a doctor who is sitting all around different corners of our country to having the best facility from him. Now, the efficiency of IOMT are accurate diagnosis other than the traditional method of diagnosis, lesser mistakes, and lower cost of care, because the transportation cost and other expenditure of medical services you may directly reduce through the services of IOMT. Here what you need to do is very simple, just pair with your smartphone, because all we are having is smartphone these days. The technology allows the patients to send their health information to the doctor in order to better surveil the disease and track prevent the chronic illness. That means you are going to send your information through online, the doctor is going to visit you online, the advice he is going to give you online, and at the end you are going to take the advice and you need to take care of all those advices. Now, the overall IOMT market is going to expect, means the growing size of market is $41 billion. Just you think, means from 2007 to 2022, if this is the growth size, then how IOMT is growing. And these days, as we know, starting from NetMed to Apollo, many such online good apps are there which are coming and carrying the medicines to your doorsteps, right? Even you can consult their doctor through online. Now, in between all this, the role of IoT in a smart medical healthcare in the infrastructure of a smart city is also very important. Please remember. Now, how we are going to find the services of IoT? If we are going to talk the cost-effective healthcare or monitor control medicine system, advanced treatment, or digital control of disease, the patients are pretty satisfied with the services of IoT with less number of errors and mistakes. Now, a typical IoT scenario you may find here. This is one of my research paper. What we have developed, one good diabetic center, means the IoT device means the device is going to suggest how far the patient is treating well inside the hospital. See, starting from the initial component, the hospitalist patient monitoring at this side. Am I audible clearly, guys? Am I live? Just to ensure, can you please reply?
Yes, sir, you are
Yeah,
audible.
yeah, okay, thank you. So if you are going to talk about the raw data, if you see here, what happened normally, a patient is coming for monitoring his health. Okay, so he just came with a number of some good informations and he's carrying the mobile, everything is okay. So what is going to happen? Doctor suggested you please be admitted into the hospital. Doctor went to his home. Okay, hospital management system has kept the information of the patient in hospital. What they used to do is in the ICU, at some point of time, suppose the patient is little serious. Okay, the doctor is taking rest in his home. Some other nurses or health practitioners, they are not at all, somewhat they're busy with their task, I can say. I cannot say they are not at all bothered about your health. So normally in a good hospital, they are really bothered about your health. So a smart healthcare system, what it used to do, the patient information is being shared automatically with the doctor along with the remaining staffs of the hospital who are really bothered about that patient or who are really taking care of that patient. Now, all these scenario you are going to find in a cloud environment. Now, if the alert message is in time, the doctor may reach in time. If the alert message is in time to the ambulance person, the ambulance is also in time. See how far with a small application we are able to get all these kind of best services just upon a click. Okay. So this is one of the very typical scenario of IOMT. If you'll find IOMT in no combating the COVID, it was one of the best practices during those 2 years of COVID pandemic, including the IoT and 5G technology. Though these days 5G technology we are finding in our country, but those days many of such foreign countries, they used to find good number of solutions, and in smart hospitals they used to implant the IoT based and 5G technology based devices to give the best services to the remote patients. See, if you are going to find the supply chain for medicine and equipment, those all are connected with the 5G core network, where a normal server is going to give all the information starting from the medical healthcare authority to the general public, to the COVID patient, the self-isolation patients, the wearable devices. These all are going to be controlled with such kind of good technology of IoT and 5G. See, the basic methodology, it is pretty common to understand that we can easily get the solution in such a way that really the IoT and 5G technology are able to take that advantage of having remote services, because we know getting remote services through number of good practitioners or doctor is not that much easy. And these days, with the help of such good network, we are able to get such service. Now, there you find, though the infrastructure is that much not complex, still how far the technology is way behind the development of all these good inventions in this era. Means early days, our doctors, the traditional method of carrying the patients to the hospital and taking the medicines and giving some suggestions, starting from those days to this era, it is no almost some 180-degree incline difference. There you may find this all possible, including the services of medical with the help of IoT. So if I'm going to combine the services of IoT with the technological advances of medical, that is IoT plus medical is IOMT. Okay. Now, a typical structure of IOMT or typical architecture of IOMT for COVID-19. If you see the COVID-19 positive patient, you are going to have the quarantine stations, because most of the time the doctors, including the doctors, most of the personals, they used to fear to go to the quarantine stations, because quarantine means almost we need to think the COVID-19 positive patients are staying there, right? So what they need is, we cannot make them completely die in that quarantine center, right? So what our task is, take visit of hospitals, take the disease control preventives, the local healthcare bureaus should contact to them, clinical practices should go on, online healthcare consultations should go on, all the personal medical devices should be controlled, hotels, the disease, other remaining local and good practitioners of medicines should also be in the complete contact of all those quarantine centers. Now, this all makes it possible through IOMT platform. That means developing one IoT based medical service for COVID-19, it became just a next level of challenging solution to the problems of medical services. Okay. So what are the exact driving factors of IOMT? If we are going to talk why IOMT is spreading over the world in such a vast way, the major reason is major tracking wearables. Because early days for checking BP also people were going to hospital. These days, if you are having a normal smartwatch, forget about the BP tracker. If you are having a normal smartwatch, there itself you may find, okay, this is the smartwatch. Through smartwatch, I can find number of information for diabetes, for cardiac elements, hypertension, the blood counts, this heart rate count, number of information. At the same time, the psychoanalysis wearables like patients who have head joint replacement, this also possible with the surgeries and stroke treatment. The monitoring of medicine, monitor of mental health for the students and professionals, the ECG devices like for the depression, myocardial ischemia, arrhythmia, some smart pills. Now, what is the smart pills? People who, because we know normal pills we used to take for the fever and cold and remaining all kind of disease. At the same time, when we are going to talk about the smart pills, it's nothing but proper treatment and medication on time. That is important to take the form of smart pill. Okay. The smart implants, that is pacemaker, ortho sensor, glucose sensor, and it is very famous these days. One doctor heart surgeon is sitting in Pune, and the heart surgeon is going to implant a heart surgery over somewhere in the Bangalore. Okay, means just with the infrastructure of IoT. Now, there are many such good driving factors of IoT which helps the health practitioner to go beyond of thinking of normal traditional medical services. Okay. So as I talked about, the number of IoT devices starting from the accelerometer, altimeter, the digital camera, the sociometric badges, camera clips, smart watches, where you may find the information in the form of GPS location, microphone, oximeter, Bluetooth proximity, the pressure, the altimeter, every information you are going to find in a single device or one or two devices. So how technology is just trending over the human being over and out of this application of IoT. Okay. Now, how means now what we did, we are having many number of good information of IoT in the form of good sensors or wearable devices. So that means we are having good amount of data. Now please return back to the original concept of technique. Means we are having the domain, we are having the data. Now come how to handle those data. Simple. So my talk started with big data. Now I talked how the data generated. Next, the data is now available on your hand now. Please now let us learn how to handle those data. Okay. So in the smart world, most data and IoT services need to be efficiently processed through intelligent algorithms. The reason behind that is simple: communication bandwidth, end-to-end service delay, long distance data transmission, potential privacy breaches. We don't want to make our useful data complete public. We need some good healthy relationships among the transmission kind of data at shorter to longer distance. We don't need any kind of delay from end-to-end service of our data, and the communication bandwidth should be pretty positive while we are going to handle such bulky amount of data. Okay. Now, so our last research means my last month research, we have worked, our team has worked one of the very good method, which is one of the good applications of this artificial intelligence, or you can say machine learning or any other network, that's up to you. It is almost all around ELM with one good optimization method. Okay, so I'll take means another only 5 to 10 minutes to explain how a method can directly applied to handle such industrial big data in such a way you can do your research informal. Okay, so in this slide, what you can see, a typical AI based method means early days method, a single hidden layer feed forward neural network. I am expecting that all of you know what is a neural network and the basics of neural network. Like a neural network is an interconnected structure among collection of number of nodes starting from input to output. Okay, so here what you will see, I'm having input layer, the single hidden layer, the output layer. Okay, so starting from the input layer, I am having how many number of inputs? Xi means a number of x number of inputs. We are having some number of weight biases. Okay, the weights you can find in the form of this A11, A12, A21, A22, A21, like that. Okay, so you may have some hidden layers as well as the weights. At the end, you are going to find the output in the form of Yi, which is one of the form of target output or the given or expected output. Now, what normally we used to do in this kind of traditional back propagation neural network structure, we used to multiply the number of inputs by the weights, add some bias to have reformation of the inputs or the weights, apply good activation function on those, Repeat from step 1 to step 3 number of layers, number of times again and again, do the same process. Calculate the output and backpropagate. Backpropagate means once your error is going to generate with means this y, this yi you are going to able to find the target output minus the expected output. What is the result? That is called the error. Okay, now that error you are again going to backpropagate to the initial this input layer to hidden layer again. So what you are going to do, you are going to repeat the same process again and again and again. Okay, this is the structure of a simple single hidden layer feed forward neural network. Give input, multiply the input with weights, then apply the activation function, repeat the step, calculate the output. But is the structure of such network and the computation at each layer is enough to handle such kind of data what I am going to talk? No, it's not at all enough. So there, what we used to do, we just used one structure of neural network that's called ELM, which is extreme learning machine. Okay, so actually extreme learning machine was developed in 2006 only, but most of the researchers, they really didn't realize how ELM can be helpful to handle such kind of good data what is being generated in this century. The basic advantage of using this extreme learning machine is it doesn't require any gradient based backpropagation to work. That means here you can see the red line what I'm showing you. Out of all these 7 steps of traditional feed-forward neural network, ELM directly removes step 4. Means here number of times the layer calculation is not at all going to compute. So that step 6, this backpropagation, it is going to replace with one of the matrix inverse calculation. Okay, a very simple method. Please remember, extreme learning machine uses the Moore-Penrose generalized inverse matrix. It is one of the famous method of finding the inverse of matrix. Now, how the structure of output of ELM used to find? If you see the output, here you may find in the form of beta and G. And this is the small calculation of number of layer wise calculation of starting from input to the output, where in this complete equation of finding output you may find L is nothing but number of hidden units, how many hidden number of nodes you are going to fix. Capital N is a number of training sample, and the weight vector W, the Z, the B is the bias vector, X is the input vector. So here what you are going to calculate, it is same as the previous feed-forward neural network, but where the difference lies, that you need to understand. The difference lies in calculating this H. So what is this? This hidden layer calculation means weight calculation I am going to do is the output in the form of beta. Okay, you find beta, one beta is here, right? If you able to find the beta matrix in a successful way, then easily you can able to implement this EL. Okay, so how I'm going to elaborate this beta matrix? So you are going to find number of outputs in the form of n. That means the simple calculation is t equal to h into beta. What is this h? This H is a matrix you are going to find which is of n cross L, where your hidden H for hidden layer output, the hidden layer output matrix you are going to find through target number of training data you are going to find in the form of weight multiplied by the input. Okay, W indicates the weight, X indicates the kind of input, and B is the bias. Okay. Now, so what we did, we first applied the basic ELM to one of the IOMT data, which is TO and IoT. But what we found, the performance of finding the network intrusion is not that much good. So there, as I told you, you can directly work on good optimization method when your solo method is not in performing number of applications of IoT or big data. So the older, but one of the effective optimization of tuning the number of hyperparameter. So what we did, we applied this Bayesian optimizer on the weight matrix of this ELM to initiate the search space. Means how this optimizer helps us, it is used to search all those hyperparameter values in the search space in an informed manner, not in an uninformed manner. Because normally, if your randomized solution is somewhat pretty different from your search space, then it is very difficult to find out the initial to target sample what you exactly want. And the main basic advantage of using such optimization is finding the candidate or sample solution through one surrogate function, not the objective function. Okay, now what is the surrogate function? What it used to achieve? The often surrogate function is used to identify only the potential candidate solution. Means the surrogate function will directly give you what are the basic good potential samples out of all your candidate sample space. So out of that, based on the identified potential candidate solution, the surrogate function is every time updated in each iteration, because iteration wise the number of solutions or the number of samples in the search space is going to simply adapt the behavior or changes in the values. Okay, so at each iteration what you will find, you will identify and focus more regions of interest by updating the surrogate function. So here the task is update the surrogate function at each iteration of the values, then the weight matrix is automatically going to optimize. Now this is the basic structure of our algorithm, where you may find you can find this is one ELM where the hyperparameters are going to optimize with Bayesian function, and you are going to define the model which is going to train with the data set with some of the, here you can see the medical sensors in IoT environment. So the medical sensors are going to generate all those big data, where all those data you can easily handle with such kind of hybridized network. And what you need to find, how much of the activity or attacks is going to be either malicious or non-malicious. So at the end, this is your IOMT healthcare based system, what the paper got published in this Journal of Supercomputing. So here you may find what a normal scenario. See how typically out of the traditional basic healthcare monitoring system, we are directly transforming to the IOMT healthcare transformation system. That means this is the part of our development using the both training and testing data. Okay, so what you are going to do, a simple if try to understand from a simple one level architecture design. So what going to happen, the patient is going to wear number of biosensor, the data is generated from all those sensors and the medical records of diagnostic centers. Okay, data came, you can see here. So out of all those data, what the attackers will do, the attackers, the hackers, they will simply attack those weak sensors and exploit the vulnerabilities to get the control of medical data. What is your task? Your task is all those data you take, analyze them in the form of both training and testing, then develop your own algorithm, tell the security administrator, please see here, attack, it is yes, it is no. What does it mean? If the attack is really there, then the security administrator is going to update the signature attack in the database and alert the user. If the attack is not there, simply alert message or message through the websites or mobile apps. So at the end, the user is going to get a very good IOMT based healthcare service. So in middle, what you did, what is the heart of this structure? The heart of this structure is what kind of methodology which is under this intelligent computing, means how far your algorithm what you are going to develop is really intelligent to handle such complex amount of data in a securing environment, so that both the administrator as well as the compensator of the network, they all used to get in a good way. Okay, this is one of the research paper. Those who are interested to read this paper, they can download or they can send me a request mail. So my team will send you exactly the full size of the paper. Okay. Now this is one of the screen I have kept. I didn't keep much result because unnecessarily the slides will increase. So this is just a snapshot of the proposed method. Like this, number of almost 12 machine learning methods we have developed, and out of all those 12, we used to find this is the one of the best solution of the proposed method, where you used to see in the left side diagram. This is the attack based diagram, where this is the actual attack, this is the predicted, means how far the activity is going to predict out of the actual, then predict. Okay, means what is the actual IoT device communication profiles and what you are going to predict. So here, what are the attacks exactly we dealt is scanning, ransomware, password, the normal injection, DDoS, backdoor, almost 6 to 7 kind of attacks. So there you may find the proposed algorithm almost able to perform 99.9% of accuracy, where it is all about dealing big data. Please remember, it is not dealing with small or hefty amount of normal amount of data of some KBs or MBs, so that the network will perform so well. The network initially never performed well. So after a thorough rigorous study of the network and the data set, then exactly we able to find what is the exact need of such hybridizing through method, means taking on optimization with just the tuning of hyperparameters of such good network to solve such kind of complex problem of big data. Okay. Now, what are my concluding remarks? If you will tell, now there are a number of challenges in big data infrastructure these days. The first thing, connectivity providers, because almost all companies or vendors, they used to tell, we will give you the best connectivity services, especially under the scanning of smart city. But if you will see the applications of smart city, you may not exactly find good kind of connectivity services. Okay, original equipment manufacturers, because manufacture dealing and handling those manufacturing companies is means which are dealing with the equipments, because it's all about finding good sensors or good sensing devices of IoT. Okay, now system software providers, system integrators, end users, because the end user network also always matters, because we never realize what are the exact end user, means end user what exactly wants, and where and how we can give a reliable service to the end user, and what kind of security to the devices we are able to produce, and how far the cost is high. Because at the end we will talk about technology. Technology is a leading, you can say, source of cost. All device means everything we will find in a good way, in a good application remark, but it needs very high cost. It is true. Okay, so at last, we are well acquainted with emerging technologies of AI, big data, IoT, IoMT, drone, the virtual reality, chatbot, the chat GPT, blockchain, lot of applications these days. Means people and researcher or the new student of PhD, they are very much confused exactly what the area I should choose. But what they used to do means most of the colleges, when I used to give talk on how to choose a means what is this PhD area for the PhD students or for the faculties, means choosing a PhD area, choosing a guide, it itself a 1 hour talk. Some other time, if time permits, I'll talk, because normally what we used to feel is my guide is working on machine learning. I need to work on machine learning. That's it, because my guide won't allow to go some other technology. But be brave and tell to your guide that I want to work on this integration with your machine learning. Then you see the reaction of your guide. Definitely you will find one of the challenging solutions that my student is able to do this. Okay, that confidence and faith on selecting that area is very important. Okay, so everywhere in all these new emerging technology, you may find some basic things like unable to detect some individuals, some privacy issues, security issues. Everywhere it is expensive, and especially the privacy and security issues or the attack detection, some lakhs of papers are being published. Still, those research are not able to find the exact correct accurate solution for all kind of environment. That means your algorithm or your methodology might be able to give solution to one problem, but when the next problem comes, again your algorithm is unable to adapt to the solutions to that problem. Okay, so please remember, it is very important to understand every methodology are having its pros and cons. One methodology might adapt 2-3 scenario, but while coming to the fourth or fifth scenario, it might fail to do so. Okay, so I'm concluding my slide with some good talks about some good people like Brendan O'Brien or Bill Gates or Pat no Gelsinger or Ronald Coase. So from starting, you can see, if you think that internet has changed your life, please think again. Internet of Things is all about changing all over it again. That means you please think in 2000, exactly 2000, means the year 2000, we used to get this internet in some 1 or 2 cyber cafe in every city, right? Means we used to get our matriculation result through some internet. For that, a long queue you need to maintain. The same means that is a internet is nothing but one revolutionary application of the century. At the same time, IoT is going to revolutionize the complete computing world. At the same time, Bill Gates used to say, if you invent a breakthrough in artificial intelligence, so machine can learn that is worth of 10 times developing Microsoft. Just you think, developing 10 Microsoft is equivalent to developing one such algorithm in AI which will perform your task. Now, Pat used to say, data is just a new science. Big data hold all the answer, because these days don't talk data. Nowhere it is data. Everywhere it is a big data, starting from the student information to the Google information. Okay. And Ronald Coase is a very famous good philosopher and scientist, used to say, torture the data and it will confess to anything. That torturing data is nothing but data science, data analytics, analyze the data scientifically and find out your own path in such a way you will be definitely able to find some good result along with some good solutions. Okay. So this is the end of my slide and this is the end of my talk. Those who are interested to work on optimization such good areas, anytime you can contact to me. You can find out my you can find out me in the Google or any of my I have my personal website of www.jnag.in. Whatever the information you want related to research, any such good idea or generation of any methodology you want, please feel free to contact me, because always we used to be active in collaborating with good researchers or good students. Okay, so what Andrew Heller used to say is, technology is just like a fish. The longer it stays on the shelf, the less desirable it becomes, because we are the researchers, academicians. We always think new, we always talks about tomorrow, not today, and we never used to be less desirable. Okay, so this ends my talk. I hope if I am able to give you some good glimpse about some research domains, then I will think that this 2 hours of my talk is really helpful, and I'm hoping for the positive consequence of this talk in future research. So thank you for inviting me, and thank you for listening me so patiently. Okay, thank you.
Yeah, Dr. Naik. It is really a wonderful session, Dr. Naik.
Thank you. As usual, it used to be. I feel that no, it will be always good to have giving some good research domains to the people, because it won't make any sense if directly we'll talk about what is KNN, what is SVM, and how SVM works, how KNN works. We can solve some classification, some clustering problem, then you take it, then solve it. So I don't know why people used to talk in that way, but normally I have tried the best to touch few good advanced research topics, and I'm hoping that all will be get beneficial through that.
Yeah, actually, to be honestly speaking, Dr. Nayak was really working in this domain of optimization, soft computing, and IOMT. Actually, he shared one paper. That paper is really interesting one that I request all the faculty community to go through with that paper and researchers to work on it. And Dr. Nayak, with your permission, I like to convey some few points, and we can wait for the
Yeah,
next
please,
session.
please.
Mr. Saurabh Javu also joined with Dr. Mr. Saurabh sir permission. I like to convey few points to take his time here and to Dr. Nayak. Actually, Dr. Nayak is a key person in a conference called the 𝐶IPR, which is going to be editor. He is the proprietor, copyright owner of that conference, and I am program chair for that. So that conference is mainly focusing on these domains what he has been delivered today. Since whatever the emerging area, he used to sit with his scholars and he will work a lot and he will give a good guidelines about that. And when time permits, please go through one of the paper he has published in a very good journal, that is 25 years of particle swarm optimization. It is really a big survey paper. It carries about 90 to 100 pages and very good information. He has worked with this team for around 1 year for deriving that work. So when time permits, I request all the faculty participant to go through with that paper. It is really interesting work. And this year that
Yeah,
paper.
adding to that, I just take some few seconds to elaborate that. Actually, one day it just came to our mind. Means while I was having my own, no, some kind of, I used to feel like we are having our marriage anniversary, our work anniversary. So everything we are celebrating in an anniversary way. So why we cannot have an anniversary to an algorithm? Because Kennedy and Eberhard, the main developer of PSO, they have developed the algorithm in such a way. Since last 2 centuries, we are able to solve the many good problems with PSO. So luckily, 2022, I found it is completing 25 years of PSO. So there it triggered my mind to, no, let's work on 25 years of particle swarm optimization. And then I collaborated with Dr. Bimal and the work got published in a very good journal. And you all people can refer that article. It's a very good article. It's got recently published. Okay, thank you.
Yeah, it is a very good research article. And in next 2 years, this is going to be a very big citations that very good information and lot many informations are conveyed there. And I request all the faculty, whoever is working in this area, please associated with Jay Nayak. He is open to collaboration. He is open to do research in this domain. And with this thing, I like to convey that. Is there any questions from participants, or we can directly get into the next session? Mr. Saurabh Jar from Ramco System, he has already joined. So I have already taken with Nayak with for past 15 minutes from his time. Okay. Any query from
I'm so
participants?
sorry to surpass the 15 minutes from your time.
So, hello, sir. Hello,
Yeah,
sir. This is
please.
Dr. Rashmi from
Yes,
NCT
yes,
Bengaluru.
Rashmi, please.
So, regarding swarm optimization,
Yeah,
even I
please.
have also adopted this swarm optimization for my hyperspectral image analysis for Mars dataset, and it has given a good
Good. That's
result,
very
sir.
good.
But for further
Okay.
calculations and all, we have to go for hybridization with this swarm optimization, sir. I think so. Is it so, sir? Or should
Yes.
I continue with the same swarm optimization only, sir?
Yeah, I can take this question on a very good note. Madam, can you please tell which swarm optimization you have used?
Sir, the statistical optimization with that swarm, sir.
No, I want the particular, the swarm optimization name. What is the name of that optimization? Can you please tell?
Sir, PCA, sir. With that.
PCA. Okay. So normally, while you are going to talk about PCA and those, it's all about good. But these days, finding the exploring capabilities of each algorithm on a feature extraction point, it's
No, sir.
always suggestible to go for multi-objective kind of algorithm.
Yes,
Even
sir.
such as they are talking about many objective, but if you will go about some good optimization, like, have you ever heard about one algorithm called Kuko search? Have you ever heard, madam?
So, pardon, sir. Can you repeat, sir?
Kuko search.
No,
CU.
sir. Not. No, sir.
Please, you can refer one algorithm that is
Huh.
Kuka search. It is a
Okay.
good multi-objective meta heuristic,
Sir,
which is
sorry to disturb you in between. So my data set is hyperspectral image of Mars data set.
mass data set. Okay,
So for
that
that I'm asking, sir. For rest all, it will be working very nicely, sir. But
huh.
especially for Mars data set, that too to have a soil composition, sir.
Okay,
I'm
okay,
using environmental tool, sir, NV tool.
okay, NV2. Okay, that is good. But at the same time, may I know what are the exact parameters you are trying to optimize in your problem?
So wavelength and this will be coming, sir. Composition of a soil and all.
Okay,
Main
composition of
parameters
this.
are wavelength, sir. Frequency and
Okay,
wavelength will be there, sir.
so what is the output you are trying to optimize? Means with
Sir, I'm
optimizing
taking the
those.
picture. It's not that at a time we are not taking many images of a Mars, sir. Only one image that we are cropping it in a several steps, sir. Because
Got
NV
it.
cannot read the whole image, sir.
Yes,
So
yes,
we are
yes.
cropping it and we are taking it.
Your
And for
voice
that
is
cropped
breaking
area,
actually, so can't able to
sir.
get properly.
Sir, I'll mail them, sir. You better give their
Okay,
mail ID
okay.
so that I can make a discussion with
No
them.
issue. Please, you can mail me and you can discuss all these problems of optimizer. I'll
Yes, sir.
definitely try to help you. Okay, no
Thank you
issue.
so much, sir. Thank you so much, sir.
Okay,
And your session was very good, sir.
okay, okay. Thank you,
Thank
thank
you,
you.
sir. Thank you so much.
It means a lot. Okay. Is there any other questions? Or I hope I'm taking little more time of 15 minutes of my next speaker. I'm so sorry for that due to beginning of some technical problems.
Thank you, Dr. Naik, so for sparing your time and spending almost 1.5 hours with us and giving various insight about how we can work in a way.
Okay, okay. Thank you,
Thank you,
thank you,
Dr. Naik.
thank you, thank you. It's always have a means I have this great pleasure to be here and to discuss some good topics of such kind of new topic. So I hope your FDP goes success and no remaining all the sessions and almost all the participants might enjoy. So thank you. Good luck to all and have a good day.
Yeah, thank you, Dr. Naik. Some disruption happened. Sorry about it from
Okay.
my side.
Noise, better. Noise. So I'm leaving the session, right, sir? Okay.
So may I take over the
Uh,
speaking?
Good afternoon, Saurabh, sir.
Yeah, can you hear me?
Yeah. Welcome, Saurabh, sir. Sorry for taking your time since the session was going on. We are for the past 15 minutes, so we have taken your time.
No worries.
Yeah. So, hearty welcome to Mr. Saurabh Jahu. He is a senior data analyst from Ramco Systems, Singapore. So, we have a session from Saurabh Jahu, sir, at this moment. And I like to invite Amuda ma'am. So, can you please give a short intro about our resource person for this session?
Okay, sir. On behalf of our management and our department faculties, I welcome our chief guest, Mr. Saurabh Jaju, who is working as a senior data scientist, Ramco Systems, Singapore. He has done his Master of Information and Data Science in University of California and Bachelor of Engineering in Computers in Savitribai Phule Pune University. He was working as a data scientist 𝐾𝐞𝐩𝐚𝐫𝐭 Solutions Private Limited, Pune, in the year 2017 to analyzing data and developing models for predicting customer leads, retention, and churn. Also working as an analyst and academic associate analyst, Indian School of Business in the year of 2018 to analyze the applied statistics and computing lab and working on machine learning data science products, and an academic associate in the field of strategy and marketing. He is a co-founder at Arin and Human. He defined the analytics and data science projects at the company. His area of interest are data science, machine learning, predictive analytics, competitive strategy, big data, smart resource management, NLP, deep learning. He wrote so many articles and developed skill tests on various topics in machine learning, data science, and statistics. We are very much glad to welcome you, sir. Thank you.
Thank you. Thank you for the introduction. I hope you can see my screen.
Yes, sir. Please share the screen.
Okay.
Also, I like to welcome Uttara ma'am from our side from placement perspective. Yes, sir. Please share the screen.
Can you see my screen? I have already shared it, so just curious.
Yeah, you click the file, sir. Which file you are going to present? You click there.
Yeah, maybe. Can you see my screen?
Yeah, it is loading.
Now?
Yes, we can view it. Perfect,
Thank
sir.
you for the introduction. I was listening to the previous session a little bit. At the fag end of it, unfortunately, I could not attend the whole session. By the way, if there is a voice issue and you cannot hear me, please let me know because I can only see the shared screen. But in a sense, I was listening to the previous session. It was quite interesting in terms of the research and the techniques that they're using in terms of in deep learning sense and developing new algorithms. Now, there are for me it was a very different challenge in terms of trying to figure out what the audience is. So I've kept my session fairly basic, but from my end what I have tried to do is look not at a research aspect of working with machine learning and data science, but to highlight the critical usage, the background mathematics to a certain extent, and to highlight how and where um, these algorithms are deployed within the industry. So more of a practical approach to things. In terms of my research as well, as Uttara was mentioning, my research was pertaining to business and not directly to algorithm development. And in a sense, even in terms of my research, I used to develop a lot of algorithms, but they had more practical orientation than the mathematical ones. So I hope I can give you a sense of what this next 1 hour would entail using this introduction. As inherently I was saying, it will be simple enough, but let's try to figure out, use the Occam's razor and try to see how we can use something simple to do something amazing. That I hope will be the takeaway from this session. Now I'll just quickly start. Just to get a sense of how I think about data science, machine learning, and how usually we think about the concept of information. I'd like to ask you people, what do you think is information, right? My version of thinking about information in simple terms is it's basically comparing and quantifying differences between a set of instances, right? In a sense, information is factual, facts about something, but how do we garner a fact? The inherent way a human mind thinks or we learn is from comparing or quantifying something, right? So unless and until you can do either of those things, there is very little chance that you can garner information from a piece of data. That knowing what is information, what is knowledge, and what is intelligence in its simplest terms helps you try to figure out whether a problem is solvable or not using machine learning and data science. That's the reason we start here. The next question that I would like to put to you people is, what is knowledge in very, very simple terms? I would say ability to use information is simply knowledge. And how would I define intelligence in that sense? Then intelligence would be the ability to use knowledge to change outcomes and quantify the change would be intelligence. So all the artificial intelligence or machine learning or deep learning that we are looking at boils down to just these 3 points. How do we create information? How do we utilize information to generate either some heuristics or something, some mechanisms or some algorithmic rules? A decision tree is essentially rule based from the data. And how do we use that knowledge that we have created, which is stored as a model, to actually change or improve or optimize one of our processes? It's that simple. So given that I'm talking about information, I just wanted to give you a couple of nuggets in terms of how we measure information. Now, connecting this philosophical bent of looking at information, or just a theoretical model of looking at information, to mathematics, it is essentially a couple of metrics to try to understand how information works in mathematical terms would be entropy and information gain, right? Entropy, in very simple terms, is basically the expected value of surprise for every event, right? By the way, you will find a lot of simple explanations in my whole setup, because I hate a lot of jargon, and I hate the concept of throwing around a lot of jargon. So ideally, I try to make it as simple as possible. In essence, thinking about entropy, right? I can give you a formulation of entropy, a mathematical equation. It is very difficult for obviously faculty is great at understanding mathematics, but it's difficult to convey to a lot of students. So here's a simple definition of entropy. Entropy is the expected value of surprise for every event, right? So you can write it down as just a summation of surprise multiplied by the probability of surprise. That's the expected value, right? That's log of 1 by probability of x multiplied by the probability of x. Now, where is entropy as a measure of information valuable? Entropy is used to build classification trees. A lot of you might know this. Entropy is the basis of mutual information. Entropy is the basis of KL divergences, which is relative entropy used in dimensionality reduction algorithms like TSNE, and also the basis of cross entropy. Similarly, now, given the fact that we have looked into what entropy is, there is also a concept of information gain. When we are defining what information is, we also need to know what would change the amount of information that we have. So information gain in terms of machine learning would simply be the difference in the impurity values before and after we make a split in the data, right? It is more in context with decision trees, but it is also a general sense. It gives you a general sense of how you quantify change in information, right? It's that simple. Now, based on the agenda that I saw for the conference, you might have gone through a lot of sessions on supervised learning, unsupervised. I think there was nothing on unsupervised learning. You can correct me if I'm wrong, but a lot of supervised learning algorithms, a lot of algorithms in deep learning maybe, and applications of these things. I'll start from the basic, but and quickly get through it, to be fair. But I would like to differentiate what we will be going through in this session from some of the conventional methods, right? Not that unsupervised machine learning is not conventional, but still. So supervised learning, essentially, you have an input of something like an audio, image, videos, demographic data for a person, anything, and the output would be, essentially, what is the action in the video. A lot of you might be doing a lot of complicated machine learning algorithms to analyze, what is, what can I find in the audio? Can I convert the audio into text? Something like a labeling of essential entities within your text, right? Finding actions. So let's say, somebody is doing research on the DRS systems in cricket, right? So just to be able to find the next trajectory of the ball movement, you might be analyzing a lot of video data, and the output in that case would be the next point at which the ball would move, right? Something like that. So when you have previous data to showcase what the current piece of information can be looked at as, that would be a supervised learning scenario where you have a lot of labeled and collected data, right? But on the other hand, unsupervised learning does not require labeled data, right? There is no Y value in the output. We only have some input data, right? Some variables describing your data, right? So it's quite useful. If you think about it, it's quite useful in general terms, because you may not find a lot of labeled data out in the wild, but you will always find some or the other piece of information which is not labeled, so you can essentially apply unsupervised learning to a lot more problems and to a lot more scenarios than you can apply supervised machine learning. So in terms of unsupervised machine learning, the other aspect that you can compare with supervised machine learning is that you can discover the end goal is to discover the hidden structure in your data. Just checking on the so is there somebody who's coordinating? I just wanted to check in terms of how would you convey any messages to me if there is something. Anyhow, in case we get a reply to that, we'll look into it. So in case there is any message, please connect with me. Please interrupt me directly, right? So inherently in unsupervised machine learning, we are essentially discovering the hidden structure of the data, and maybe trying to see what data is related to what and what data is not related to what, right? How many of you have seen this, right? We go through this a lot of times, right? We go through this a lot of times when we are browsing. It's just a captcha, right? Think about it. This is Google's way, or any of the big tech's way, of getting you to create a labeled data set for them. So labeling inherently is expensive, and finding data sets for supervised machine learning is very, very expensive. And companies like large companies like Google, Microsoft deploy such methods to essentially label a lot of their data. So some examples and methods of unsupervised machine learning. So the methods that we can cover under the domain of unsupervised machine learning are clustering algorithms. Outlier detection would be another set of methods and algorithms that fall under this. Looking at anomaly, then we can have dimensionality reduction. This might be a problem with a lot of people working with large data sets. Being able to reduce the dimensions of your data to converge information in a smaller set while is a very, very valuable practice. And similarly, signal separation might also be something that may be of interest, which you might observe when you're analyzing or working with a lot of images or audio-based or video-based data, right? Consolidating your signal using unsupervised methods is a very common practice. Some examples of unsupervised machine learning algorithms would be clustering and maybe outlier detection. Clustering could just be that you started a new company, you're going to start a new company, let's say, and then you want to your company is making a lot of cool shirts for the millennial generation, but at what point do you differentiate yourself? It could be easy for you to differentiate yourself by changing the conventional sizes that that you make your shirts in, right? Because the millennial generations size and the fit of their shirts could be very, very different from our previous generations, right? So one example could be that. The other could be that, a lot of, which might be close to a lot of you, right? You want to do research at some really amazing universities around the world, right? So where do you apply for your research? Choosing a PhD or a master's in a lot of these Ivy League schools could, or even other schools, could be a very, very difficult choice, right? It's not just about the name and the brand name of the university, but also about, do the people there work on similar kind of topics as you do, or is the outcome of the university really the way that you want, or if there is an entrance for some of these universities, how do you cross that? What is the threshold for selection? So, a lot of data regarding this you can collect, and you can cluster a bunch of universities which work out for you, and then apply for them. Right. Similarly, another example of an unsupervised learning, machine learning problem is outlier detection. Fraudulent credit card transaction detection, or detecting anomaly in payroll, are two examples which we implement here at Ramco Systems as well, right? Where we try to detect outliers using unsupervised machine learning methods. Yeah, as I was mentioning, I mentioned a few examples of what sort of unsupervised machine learning methods and algorithms exist. The question, it's still an interesting question to pose: why unsupervised machine learning, right? So as I had mentioned, it's very difficult to get labeled data set in many cases. So it could be a preliminary step to starting a supervised learning method. You can use an unsupervised learning method as a preprocessor to try to label the data set coherently, and then use it for supervised learning, in a sense. Another, just to give you an example, right? Classifying cancer involves biopsy data, and it's very, very difficult data to get, not just because of personal reasons, but also the process is expensive, and it's not a very, very easy process to do on the person who has cancer, right? So you have very limited data in the field, and the access to that data might be very, very difficult. So I would like to urge any of you, in case you are in a situation where you're doing some work, some research, or some project, and you cannot find labeled data, don't restrict yourselves. Use an unsupervised learning method and try to see if you can still do your analysis. Unsupervised machine learning is used a lot in exploratory analysis. So in our case here at Ramco Systems, we deal with large amounts of data, and really, really horizontally wide data. That means we have a lot of variables, right, that we are working with for various companies. Now, to analyze a system, we might even store close to about 300 to 400 odd variables for each entry, right? Which we think are all valuable or related to the task that we are looking at. So for example, if we are doing lane optimization, we can have about 300 columns worth of data, or 300 variables which describe a lane in terms of transportation. When I mean lane, it is in terms of transportation. Let's say you can consider Delhi to Mumbai being a lane, right? So so to be able to explore this vast amount of data with millions of rows and about 300 to 400 or 1000 columns or attribute values, you can use it for exploratory data analysis. Applying a unsupervised learning algorithm as a first step is not really a bad choice, because as against a lot of research work that we do, but in industry response times need to be very, very quick. Responding back in a couple of hours might be a requirement. The only way you can actually analyze such a large data set in a couple of hours would be to apply some unsupervised machine learning algorithm to explore the data set. Similarly, we can use unsupervised machine learning to reduce noise and complexity of your problems. So, particularly with dimensionality reduction, we can, in a sense, do that. And as I mentioned, it could be a precursor to supervised learning. Defining clustering, right? Now, clustering is one method. As we had discussed, clustering would be one unsupervised learning method, dimensionality reduction would be another, and signal separation or signal processing could be another. Right. So let's start with clustering. Right. Inherently, how do you define clustering in a very, very simple way? Again, starting it very simple. A cluster is a group of data points that are similar to each other based on their relation to surrounding data points. Right. Clustering used for feature engineering or pattern discovery. Right. There is one key insight that I would like to share with every one of you, right? We can develop tons of algorithms, right? But the one thing that we have always observed on real world data sets or on algorithms which have to be working on a vast diversity of data sets, right? The only thing that improves the performance of your model is high quality feature engineering. You can use tens of algorithms, you can optimize the algorithm to n levels, but for your algorithm that you end up with to be able to generalize across different data sets, it has to have high quality feature engineering. High quality feature engineering also helps in terms of explaining your algorithm. So using clustering could be one way of finding really high quality cluster features or discovering an interesting pattern, right? Next, I would like to look at, once we know that what is clustering, let's look at what type of clustering exists, right, in terms of using various different machine learning algorithms. There are density-based clustering algorithms, there's distribution-based clustering algorithms, there is centroid-based clustering algorithms, and there is hierarchical-based set of clustering algorithms. Now, what does density-based clustering algorithm do? As the name suggests, it just finds a group of areas of high concentration of data points. And this kind of methods are really good at finding outliers, right? Because these methods don't force a point which is not close to something, some cluster, or which is not close to other set of points to be forced into a particular cluster, right? If the density, you can set a parameters to define what is the lowest density you would allow a cluster to be, right? So inherently, density-based algorithms are very, very useful. DBSCAN and optics could be two examples of density-based clustering algorithms. Distribution-based clustering algorithms, Gaussian mixture models are an example of distribution-based clustering models. Inherently, distribution-based clustering models work very similar to a k-means model, right? Which I think is in the syllabus for computer science for a long time, right? Everybody knows k-means. So distribution-based models just work in a very similar way. The only difference is that you are trying to find the distance of various points from the center point of a distribution, and thus they become probability based. So when you plot a distribution, the center point of a distribution is usually the mean of the distribution, right? If the distribution is, let's say, normal distribution, right, or any kind of distribution, you can find the center point of that distribution. Now, the probability of a particular point in a being closer to that mean is all you're finding in distribution-based algorithms. Gaussian mixture models can get to a lot of complexity in terms of the mathematics, but yeah, they inherently derive from the similar concept as K-means. Centroid-based models, the most popular, everybody knows this model, is K-means. These are just simple algorithms which calculate the distances from the centroid, right? Each point is assigned to a cluster based on the distance from the cluster's centroid. It's that simple. And hierarchical-based algorithms essentially are use tree structures to build clusters, and they are top-down algorithms, meaning they start with every single point being a single cluster, and they keep on merging the clusters till the point that you find keep on merging different clusters till the find point that you cut the algorithm, essentially. Birch, mean shift clustering, and hierarchical clustering are three types of hierarchical based algorithms. There is another way to look to think about clustering, or types of clustering: hierarchical methods and non-hierarchical methods. Hierarchical methods begin with n records and sequentially merge similar records to create a group, right? Non-hierarchical methods, on the other hand, need a pre-specified number of clusters to assign each record to, right? In essence, depending on how much you know the data set and what you are expecting from the data, what is your hypothesis, you can choose either one of these techniques. In terms of what I mean, what your hypothesis is, if you can hypothesize and reason why a particular data set might have n number of clusters, then by all means work with a non-hierarchical method, because it's faster, it's computationally cheaper. The only problem is it requires you to specify the number of clusters, right? So if you have any way of defining the number of clusters, then it is really, really easy and better to work with non-hierarchical methods. Similarly, if you have no clue about your data and the number of clusters it has, use hierarchical methods, because you don't need to specify the number of clusters. You can try to collect the number of clusters based on the amount of variance that is getting explained. Now we go through an algorithm. We'll just see, a clustering algorithm in action, essentially, right? We can define the simplest one to be hierarchical clustering, the most effective as well in terms of finding a lot of relationships. Mathematically not that straightforward, but still.
Good afternoon, sir.
Sorry?
So sorry to disturb you in between. Sir, just now you talked about density-based and centroid. Sir, both looks together like those are a special clustering, sir. So can we combine those two for our when a case study is going on with respect to the clustering and all? I want to make when we go for a scanning report, sir, cancer scanning report. So the pixels will be there nearer to each other. So can we combine together as a hybrid approach for centroid and density based?
So you would, if you do want to do that, right, the one way to look at it would be that first you find the denser points, right,
Okay.
in terms of locating. So it would be a two-stage process.
Yes, so
let's
first
say,
applying density, then we'll going for centroid. Is it okay, or first we have to go for a centroid that K-means, and then we have to go for
that
the
genuinely depend on the data set, but from a logical standpoint, I would say going for the density first would be a much better option than going with K-means first, because the kind of clusters that K-means can actually create are very limited. They are very structured inherently. Density-based algorithms can create a lot of various different
so my
shapes.
question is, assume that already they are went with the centroid, that is K-means clustering. We are not finding the accurate value among those clustering. If you are digging the information within the cluster, and that time can we go for a density? I'm asking, sir.
I would say that's what I'm trying to say. I would rather go for density first and then go for K-means. In case you want to go for K-means first and then go for density, right? The trouble that you might face is how would you structure it in terms that would you look at all the clusters that K-means has come up with individually
Okay, okay.
in couple of groups or all together? If you're looking at it all together, right,
Okay.
then you're just aggregating
Yes,
clusters.
sir. Got it, sir. Got it, sir.
So the step that you take in terms of using the using one of these algorithms as a preprocessor would be very, very important to look at.
Yes. Yes, sir. Thank you so much, sir. Thank you so much, sir.
Um, but yeah, as I was mentioning, I would go for density based first.
Yes, sir.
Yeah. Yeah. So as I was mentioning, let's look at hierarchical clustering as an algorithm. Essentially, you get a dendrogram from a hierarchical clustering setup. And these are distance based, calculated using distance. You start with n clusters for one cluster for each record, right? You merge two of the closest records into one cluster, and at each step you either merge two records, a single record to an existing cluster, or two existing clusters are combined, right? It's seems straightforward, has a more logical way of moving around in your data, right? Um, it also helps you if you look at the output of a hierarchical clustering algorithm and the dendrogram. It also can help you to really describe why your cluster is something, right? Why did something end up in a particular cluster? So explainability of a hierarchical clustering algorithm is a much better scenario for particularly for business users. In scientific community it doesn't matter, but for business users explainability matters, and hierarchical clustering gives you that hope of being able to explain why something got clustered in a particular way, right? The second thing the most important thing in hierarchical clustering is where to stop, right? At what point, because you are defining your own cut to create the number any number of clusters, right? So how would you select a cut point is something that you need to look at. That will depend on the data that you're looking at, but it will definitively be based on just the mathematical distance, right, that you're choosing to use. Let's now talk about a few distance metrics, right? Now, if you're using, by the way, to that question, I'm coming back to that question about the various algorithms that you can use in two-step processes, right? If you can combine two algorithms for the cancer detection thing. It will also depend on the distance metric that you use for K-means, right? You might find a better outcome with some different distance, a simpler distance matrix than a Euclidean distance matrix also in some cases, right? So choice of a distance matrix while combining these algorithms might be very valuable as well. So Euclidean distance, I don't think we need to describe it a lot, but inherently it is that hypotenuse that you're looking at, right? Inherently, the easiest way to find a straight line distance between 2 points is the Euclidean distance. And then you can also look at Manhattan distance, which is sort of an absolute distance metric. The slide gives idea for a two-dimensional data set as well as n-dimensional or k-dimensional data set, how the formulas would change for the distance metrics. Yeah, so as I was mentioning, the Manhattan distance metrics, you can see, I don't know if I believe I would not need to describe Manhattan distance a lot, but just to give a quick idea, it is basically in a blockwise oriented setup. It is both sides of a triangle, if you may, between the 2 points. That's the Manhattan distance, right? One more thing, there is another distance called statistical distance, which also considers covariance matrix to calculate the distance. But one thing that you might want to look at, and all of you might be involved in, is being able to calculate these distances for various kinds of data or a mix of data sets, right? So this slide also describes the other types of distance metrics that you can use for categorical data, and Grover general dissimilarity coefficient for mixed numerical and categorical data. Why I describe these distances very, very clearly is because if you are applying a unsupervised learning model for clustering particularly, right, then choice of distance matrix is very important. And the other part is because we don't do these things with hand, right? There might be, in the rush of doing things, or not remembering something at the last moment, you might use an incorrect distance matrix when you are actually looking at the data, right? Because you're using some packages in Python or R, and these packages will still be able to compute the distances that you suggest to them, even in categorical, non-categorical, or ordinal data sets, and give you an outcome, but it won't be the outcome that you need. So it allows for a lot of silly mistakes to happen, these statistical packages that we use, right? So that is the reason inherently knowing various distance metrics and why you would choose one, and being able to define why you would choose one is very, very important, right? So there has to be a reason why you chose a particular distance matrix. If you can see, one more point that I would like to add is, while clustering, one important thing that you might want to look at is to be able to standardize all the various features or variables that you're collecting, and essentially standardizing them will really be valuable. Can anybody actually give me a reason why we standardize based on whatever we have looked at? Why would you need to standardize your various variables? Consider, this being a data set. Why would you want to standardize your variables while clustering? Any ideas? Why would you do that? And when would you not do that? So I'll just describe it, why I would standardize these variables, because while applying these algorithms, right, we are looking at these algorithms in terms of distance metrics, right? So if everything is distance based, right, so then you would need standardized and even ideally in some cases normalized sets of data to compare, because we're using one piece of information to compare with other piece of information, and the metrics need to be you don't need to have a skew in particular for a particular variable. So for example, in this data set, you will see everything standardized, but SAT scores and acceptance ratios will have very, very different distributions or values that you can see inherently. So a SAT score could be up to, I think, 700 in some cases, or a GRE score, let's put it that way, would be, I think, out of 340, while acceptance ratio will be in the range of 0 to 1, right? So to be able to use both these parameters with equal importance, we would like to standardize and normalize our data. Coming back to hierarchical clustering and using, let's consider that we have this data about SAT score, the top 10 colleges. Is it in the top 10? So the ranking of a particular college, the acceptance rate, the cost ratio, the expenses, and the graduation rate. If we have this information about each college or each university, using this data, if we apply a hierarchical clustering model on top of this data, we might find that, the figure on the right is the output of analyzing this data using hierarchical clustering. Right now, what did we find here? If we make a cut here, we are finding three distinct clusters. Right, we got CMU, that's Carnegie Mellon, Texas A&M, and all the other universities in a third cluster. Right, there might be a reason for this, wherein, if we are looking at very specific branches, right, for example, CMU has a really good AI machine learning setup, and the scores required to get into CMU for that might be very high. So it is ending up in a very distinct cluster. Now, is this the first question that we need to look at is this the correct cluster or correct cut for this data, or should we cut it somewhere else, right, so that we get more clusters? Ideally, I would say you would cut it at some place else if you're looking at all essentially explaining all the variance in the data. On the left, we also find another piece of output from hierarchical clustering. This is just clustering various kinds of cars. I like cars, so analyzing various cars for the essentially the fuel, the mileage, the drivability, the maintenance, all of these things. If you have the data for, you can cluster various cars to find which ones work out well for you. What kind of cars each company has, and can you get a nice supercar or a really nice open top car in a lower budget just from a different company. For example, a Mazda might be costing you lower, but it is an open top like some of the other cars that Mercedes produces, or a Z4 that a BMW has. Here are some important considerations while we are analyzing and working with hierarchical clustering. What kind of interpoint distance and how would you analyze your cluster quality? So what kind of interpoint distances and intercluster distances you can calculate, and which one would you use specifically, right? So complete linkages will help us analyze intercluster distances between the two farthest points. We actually calculate that to try to figure out what the complete linkage is, right? This creates spherical clusters, right? Then you have single linkage. So intercluster distance between the two closest points is found out, right? This creates a extended kind of clusters, elongated extended clusters. And if we use something like average linkage, we can find the intercluster distance between the mean distance between the elements of each cluster, right? And take an average of that. That's pretty much all about hierarchical clustering. I have some information about K-means clustering, but I think I'll go about it in a great pace because I think everybody knows about K-means clustering. Quite simply, the pseudocode is just this, right? You initially start by choosing K points which are likely to be K different clusters or the centroid of these. Then you make these points as centroids. Basically, you choose K centroids for K clusters. Then for each of the remaining points, you add it to, you find the closest centroid to the point that you have, and you add it to the cluster of your centroid, right? Of that closest centroid. Once you add that to the cluster of the closest centroid, you recalculate the centroid for that cluster. And you keep on adjusting to minimize the loss. That's essentially the simplest pseudocode for K-means clustering. I would not describe K-means clustering here. In case we need to go through it later on, we can. The other interesting algorithm that I would like to highlight is a Gaussian mixture model. In a sense, it is very similar to K-means clustering. It's a softer version of K-means clustering, if you may. Right. The mathematics that I described, essentially for each cluster you have you can find a distribution, and for each distribution you can, for any given point, you can actually calculate how close to the mean of that distribution is that point, or what's the probability of the point being closer to a particular distribution, right? Each point is assigned to a cluster with a probability, basically. So it's not a very definitive, like you can definitely convert those probabilities to give you one exact cluster, or distinct clusters. But in case of GMM, you can also get indistinct clusters where your data is really spread out, right? And it's very difficult to find two distinct clusters. Finding the number of clusters could be a difficult challenge, even with K-means or any of the algorithms where you define the number of clusters, right? How would you know how many clusters is this data really, does this data really have, right? One simple way of looking at it would be, looking at cluster variability, that is the sum of squares within the particular cluster, and the number of clusters on the x-axis, right? So wherever you find that elbow would be the point where those many numbers would essentially be the number of clusters. In case of this graph, we find an elbow, basically a bend or the change in the rate of reduction of sum of squares at 2 and 4. So either this data set has 2 or 4 clusters. There are other methods also of trying to analyze the ideal number of clusters. You can look at silhouette plots. You might not even look at some plots. You have some Baldwin scores and some other scores which you can look at in without, if you want an automated way of selecting the ideal number of clusters, right? So you have a lot of statistics around this as well. Coming back to the point, right? Why would you cluster? We have looked at some reasons to use unsupervised learning algorithms. Why cluster in particular, right? And how does it help? So on the right, you can see a plot of various blogs, right? Has a lot of text data, and you're trying to find out what a particular blog is about, right? And a blog may be about 5, 7 or 10 different things and entities and about 2 or 3 ideas, right? So there is no definitive way of saying that this blog is specifically this, right? This blog is specifically just talking about US presidential elections, right? It may not just be that, but it may also talk about the technology used in US presidential elections, and both of these might be something that you are keen on finding out, right? So when you do not have a very clear single point classification for any piece of data, and a piece of data has a lot more information which is all valuable to you, then you would ideally use something like a clustering also to try to figure out what all is this particular data has, what all valuable things does this particular data set have, right? So for example, analyzing various blogs, you can see that we found clusters associated with technology, news, there might be clusters associated with food. So when you find something like an iPhone, it is probably associated with technology, but it is also close to news in some way, right? Because iPhone is in news in most of cases, right? So something like that. It is, as I mentioned, a fast way of making sense of a business problem, and it also reduces your cost of analysis. That's it. We're done with clustering as a idea. with one or two basic algorithms, right? You can look at clustering in a variety of ways. One thing that we usually pair with clustering, in particular in the industry, or in the corporate structure, is dimensionality reduction, because it gives us a very nice and beautiful way of being able to show, uh, as a visualization, how clustering, how a large data set can be narrowed down to uh, two or three dimensions, and you can kind of observe how different your data set is, right? So showcasing clustering can also be done using dimensionality reduction. That's where the reason these two techniques may also be used in combination, right? So in a sense, what is dimensionality reduction, right? We reduce each object from k dimension, or each row of data in your context, from k dimension to the corresponding object in m dimensions by collapsing the dimensions. Essentially, simple terms, it's just compressing your data, right, while losing minimum information, right? So how do you find a new dimension? To put it in a very, very simple term, right? What does dimensionality reduction do, right? If I have 110 parameters describing my friends, right? Each friend I have, or, rather than a friend, I'd put car, let's say, right? For each car, I have 110 dimensions that are describing the particular car, right? Now, not all these dimensions might be completely unique, right? Or uncorrelated. They might be actually highly correlated pieces of information, right? Now in that case, do I really need all those 110 dimensions? And think about it, if my data set consists of all the cars from the start of motoring automotive history to today, right? So that would be a huge data set. So is it really necessary for me to describe everything in those hundreds of attributes for each car? May not be necessary, right? Or if I have such a data set, do I need to look at all those variables? May not be necessary. So in such a situation, you would ideally want to do some dimensionality reduction to combine columns which are highly correlated, right? Uh, the examples, the two charts at the bottom of this slide, are essentially PCA and TSNE, two-dimensionality reduction algorithms applied on images of numbers. There is this very popular data set about images of various numbers, handwritten images. So these images, obviously I can have a very, very clear image of, let's say about 1000 pixels by 1000 pixels. That would not really be that clear, but to be fair, maybe 10,000 pixels by 10,000 pixels, right? I make a really big image for every single letter that I have, right? So now being able to decompose this to two dimensions, because I have a 10,000 cross 10,000 row of matrix for each image, and such I have hundreds of thousands of such images. So if you can think about it, how many multiple dimensions does this get into while comparing with each other, right? So is there a better way of comparing two images with each other? A faster way could just simply be that we reduce the dimensions of 1000 cross 10,000 cross 10,000 pixels to maybe 2 cross 2 pixels, just consolidating the relevant points out of it. If we are able to do that, it would be easier to compare these images, maybe, right? To see if multiple people write the number 4 the same way. Now PCA, as you can see, runs very fast. It's 0.01 seconds. TSNE is a non-linear and non-parametric dimensionality reduction algorithm. It took a little bit of time, calculates a lot of KL divergences and the associated entropy, and was able to kind of segregate our data quite well. and show us that segregation to be fair, and also show us which numbers look very close to the other numbers in terms of the writing. Just two simple images, just to describe them. Now, why do we need dimensionality reduction? I just mentioned to you, reduces the size of your data but by losing the least bit of information. That could be one way. The second is image data. We just spoke about that as well. Reducing the number of columns, again, is the same thing. Identifying relationship between the columns could be very, very valuable, right? So, if you have a particular principal component number 3 or 4, if you look at it, it might be describing it. If it is highly correlated to 2 or 3 columns only, right? So it is describing, it is a combination of those 2 or 3 columns, right? So you can actually try to backtrack and find new features by using dimensionality reduction. We can do 2D visualization. We just check the visualization, and just a simple question, right? If you, how do we analyze two variables? If I want to analyze it, we plot it, right? Or check a correlation plot. How would, as a data scientist or as a researcher in this field, if you come across a data set with 3,000 variables, you would really not want to be analyzing each of those variables using various correlation plots and looking at all those correlation plots and various kinds of plotting, right? So reducing the dimensionality of such data sets could be really, really valuable. Some examples of dimensionality reduction algorithms could be, PCA. It's a linear dimensionality reduction algorithm. TSNE, that's distributed stochastic neighbor embedding. So it basically creates embeddings for you. Salmon mapping, isomap, LLE, CCA, SNE, MVU, and Laplacian eigenmaps. A lot of these can be used to reduce your dimensionality. The most common and the most popular would be PCA. Something that I genuinely like is TSNE. It's really good at what it does. PCA is just simple and understandable. That's the reason, essentially, I think PCA is used more commonly. Let's try to understand how PCA works. The intuition for PCA. Let's take a very simple example. You want to reduce your two-dimensional data set into one dimension. How would you do that? Quite simply, just project that data onto a line where your sum of squares is lowest. You try to project that data onto a particular line and see. When you're trying to project that data on a single line, you're creating a single dimension that captures this, all the information in this data. That is essentially, that projection of two dimensions onto a single dimension line is essentially PCA, right? So the input to PCA is P measurements, or number of columns and number of columns, right? These columns ideally should be highly correlated. If you find a lot of correlation between a lot of columns, then it is good to operate a PCA kind of a mechanism on top of such data set. The output would be weighted principal components, which are average of original measurements. The principal components usually are uncorrelated, or highly uncorrelated from each other. So they're kind of essentially getting a unique signal for you because they're highly correlated from the other principal component. So, whatever information exists in principal component 1 will not ideally exist in principal component 2. Various principal components are ordered by the variance, and usually we just look at 2 or 3 principal components because that would explain a majority of our variance. We'll come back to the point of how we select how many number of principal components we need to kind of describe the data correctly, right? Coming back to our data set, remember the data set that we had scaled. So we had scaled a data set, and we essentially, this is the university data set with all the scores that we had looked at. I think in the interest of time, I would not go through the detailed mechanism of how PCA works, because that can be read through, and essentially I have anyways given an intuition for it. I would rather go back to, you can go through these slides if you want to, but this is just a sample output from the data set that I had shown you about the various principal components, right? And also one record for the Brown University. I'm calculating that. I'm showing how it can be calculated or computed, right? Going through it very quickly, this is the output that you get from your principal components, right? So the proportion of variance that your components essentially describe in your data would be the criteria on which you select how many components are required to essentially describe your data, right? So as I was mentioning, as you can see in this case, the first component will capture maximum variance in your data, right? So 76% of the variance in this case has been captured by principal component 1. The component 2 captures about 13%, component 3 0.04%. So based on this, I can kind of get all the information that exists in the data set into just about 4 principal components. 97.5% of information has been, or 99.5% information has been accumulated in those 4 or 5 components, right? Just a side note, on the right you can see the plot of principal component 1 versus 2 for various universities, right? Caltech is really far away. Berkeley or Cornell and Brown are sort of clustered together. There is one thing that you, as a tidbit, you can look at it, is the distance between 2 points on component 1 is more valuable than the distance between the 2 points on component 2. So, if these 2 points, Brown and Notre Dame, are the same distance as Brown and Duke on the y-axis, right, then you would care more about the distance between Brown and Notre Dame, right, because your principal component 1 is more important. It's just an interesting way to look at it. In a sense, these are the 2 methods that I wanted to cover today, which was clustering and dimensionality reduction. I believe these will be some things that you would use in pretty much any large data set related research or project in the industry, and it's quite valuable as a first stage, or even in some cases, if it is more text related data, to actually use it directly also. One more sample, the other algorithms that or the other types of methods that are also covered under unsupervised learning are association rules and network analysis as well. We did not have time to go through all of that in this session, but they are also part of unsupervised learning methods, and we use them quite extensively. 2 problems that I would like to highlight that we have solved at Ramco Systems for our customers are in the area of logistics. Essentially, the ability to put so essentially I'll describe the scenario for you, and then talk about the 2 ideas. One is in network analysis and the other is with association rules. The image that you see here is regarding the association rules. So in a particular warehouse where you need to store a lot of things, so let's say you order something from Grofers or something, right? And your basket the goods in your basket are placed all over a particular warehouse, right? Or you order something on Amazon and it is stored in one of their large warehouses in Bhiwandi, right? So what they do is essentially somebody or a robot has to go around and pick all the items that need to be delivered together, right? So what is the most optimal path around a particular warehouse is an interesting problem to solve. It's an NP-hard problem to solve. So one way of solving this problem is basically combining multiple techniques. The three techniques that we combined to solve that problem, to reduce the to be able to create the shortest path in a warehouse in a in millisecond timeline, is we first analyze the network of movement around a warehouse. Um, so network analysis and unsupervised learning using network analysis. Then we applied LSTMs to it to generate good quality paths. And then we used reinforcement learning to essentially take a decision while moving around that path. So that is one. The other is within the same warehouse, if we need to, um, reduce the movement around that warehouse, one way of actually optimizing that is being able to place things uh, in which are more frequently ordered nearer to the point of collection and dispatch than the other things which are rarely ordered, or to place things which are ordered in a combination, something like you might order the chart. You can look at the chart in the right, where you can order onions and other root vegetables in combination, so they should be placed nearby, right? So that is something we implemented for a lot of warehouses, which is called put away optimization, where we find optimal bins to put away various supplied items to the warehouse, um, based on grouping and respective frequencies. There are some other specifics that we have added on top of this conventional association rules, because this put away is basically association rules simple implementation. We've added some custom features on top of it, but inherently the base algorithms is just association rules, trying to find association between the movement and the frequency of movement of different goods together, right? Grouping, essentially. I would like to conclude. I think I am over time by about 9 minutes. I'm sorry about that. So I would just like to conclude with the fact that why did I cover such a simple set of techniques in today's session? Because I wanted to highlight the fact that things don't need to be complicated to actually generate something really valuable. For example, that optimal pathfinding in milliseconds that I suggested is a state-of-the-art system around the world that we developed with basic algorithm combinations. And it improves the movement around the warehouse by more than 23% on an average, which is the best in the world. Even Amazon doesn't have that technology, interestingly, at least at that percentage improvement. So that algorithm that was developed doesn't include very complicated machine learning, deep learning, nothing like that. It is simple techniques mapped onto one another to lead interesting results, to give valuable, good quality research. So the next time that you go about working through on your research or teaching your students machine learning or data science, you can convey this very simply, that simple techniques can be used to achieve amazing results. They are only limited by imagination and mathematics. As long as it's grounded in mathematics and you can imagine a solution grounded in mathematics using simple algorithms and combination of algorithms, you can pretty much solve anything. And that is the essential takeaway I would like I would like all of you to take home after this session, right? So thanks. This was my session and I hope you enjoyed it.
Yes,
that's it.
Thank you very much, Saurabh sir. So it is open for questionnaire session. Participants, if you have any questions, you can use the chat box, and if any clarity is needed, you can raise your queries. Saurabh sir, really interesting session. And apart from academician and researchers platform, getting an industry perspective point of view is really a flavor for the FDP. So we thoroughly enjoyed the session. That is what I want to convey as the organizing team member. So it was a very beautiful session.
Uh, Thank you very much. I just wanted to share this in these simple terms because in research and in academics, you can make a lot of complicated ideas and then convey those complicated ideas. But uh, in a world where there are very very strict timelines and people of various audiences, right? It would be very very valuable to keep things simple. And it is interestingly, people working in deep learning, right, and machine learning, right, you will notice that it is becoming more and more difficult to keep things simple, right? The simpler a thing, the more easily it gets adopted. That's the beauty of it. So being able to actually create impact from your research, the thing has to be simple. If it is complicated, yes, it is good piece of research, but it may not create the impact that you are intending for. So if you want to create impact, keep things simple.
Definitely, definitely. So we have received very good comments from participants that things are done in an easy and a simple way. That is the utmost thing. From the scratch, people should deliver the content in a presentable way. So you are a key person for us for this FTP. So it is really a wonderful session, and we thoroughly enjoyed the session. We are very heartful to receive you for today's session in a time constrained manner. So hopefully everybody has enjoyed the thing, and whatever the things you shared, that will be taken to the fruitful session in a meaningful way for the students, for their future outcome and their for career settlement. So with this note, I like to thank Saurav sir for sharing your wonderful thoughts with us. Thanks a lot, sir. Thank you very much.
Thank you. Thank you. I'll leave the session, and I
Yes, sir.
hope
Yes, sir.
you have a really good conference, and the rest of the other sessions are also equally interesting to you. Thank you.
Thank you very much, sir. Thanks, Utra ma'am, for connecting to the whole. And thanks to all faculty members and all the organizing team members. Thank you, sir. Thank you very much.
Thank you. Bye.
Thank you. Bye bye. And participant, we have posted the feedback link, so you can use it and fill the link. And thanks to our beloved principal, sir. Sir, one second, sir. One second. Sir, my mic is not working, sir. Principal, sir. Sir, we can't receive your audio, sir. So thanks to our principal, sir, Dr. L. Ganeshan, sir, and our vice principal, sir. And Saurav sir has given a very not very good interactive session on, and all the participants has thoroughly enjoyed. So the participants, please fill the feedback form. And thanks to one and all for coming over to this FDP. Thanks, principal sir, vice principal sir, and Uttara ma'am, and all the organizing team members for this session. Asit sir, good afternoon.
Good afternoon, sir. Am I audible?
Yes, sir.
Am I audible?
Yes, sir. Yes, sir. We can hear you.
Okay.
The participants are joining now, sir. In another 3 to 4 minutes, we can
Yes.
start.
Yes, no problem. Thank you.
Okay, sir. Asit sir.
Yes.
We will give a short intro about you, and we can get into the session, sir.
Okay, thank you. Okay.
Hamza ma'am.
Yes, sir.
Yes, ma'am. Please welcome the guest and
Okay.
present it.
On behalf of our management and department faculty members, I welcome our chief guest, Dr. Asit Kumar Das, sir, who is working as a professor and head of the Department of Computer Science and Technology, Indian Institute of Engineering Science and Technology, West Bengal. He has published more than 150 research papers in various international journals and conferences, 3 books and 6 book chapters. He has worked as a member of the editorial or reviewer board of various international journals and conferences. He has shared his research field of interest in many workshops and conferences through his invited speech in various institutes in India. He acts as a general chairperson, program chair, and advisory member of committees of many international conferences. He has more than 20 years of teaching experience in the field of computer science and technology. His research interests include machine learning and pattern recognition in various fields, including bioinformatics, social networks, text mining, audio and video data analysis, and medical data analysis. He has already guided 11 PhD scholars and is currently guiding 5 PhD scholars. Once again, we welcome you, sir.
Thank you very much for introducing me.
Thank you, sir.
Thank you. So, let's start now then.
Yes, sir. Please.
Okay, Bimal sir. So I am sharing the slides now.
Yes. Yes, sir. Visible.
Okay, it's the slides fully visible now.
Visible.
Is this fully visible now?
Yeah, visible, sir.
Okay, thank you. So good afternoon, everybody. So I want to discuss with all of you the concept of upset theory, that is the kind of soft computing technique and its application on knowledge discovery. So knowledge discovery means we know that there are various names like data mining, pattern recognition, and machine learning also. So we generally try to extract some meaningful knowledge from the existing data set or data warehouse. So how actually we can apply the upset theory for knowledge discovery, that we'll discuss with a few examples. So before applying the upset theory, we have to know the definition of the upset theory, and there are some different terms associated with the upset theory, and so that we can means apply this concept for different data mining techniques like feature selection or classification, clustering, and so on. So in this lecture, actually, I will try to cover these things like a brief introduction and definition of the upset theory and some other terms related to the upset theory. And another concept that is called the attribute dependency. So how one attribute is dependent on the other attribute, or a set of attribute is dependent on other set of attributes. So that also we'll discuss, which is very much important for feature selection purpose. And also we'll discuss the upset theory based feature selection, that is called the quick reduct generation. And also we'll discuss based on this type of application of the upset theory, after that how we can construct a classifier, that is the kind of supervised learning algorithm. So based on upset theory, that also we'll discuss. And finally we'll measure the performance of the classification algorithm using different performance measure metric. So that we'll try to cover in this lecture. So as an introduction, we can say that upset theory is basically a kind of the soft computing technique. Like there are also some other kind of soft computing technique like fuzzy theory, and also some genetic algorithms or neural networks. So these are different types of soft computing techniques, because we know that in real time, actually that will not give us the exact solution, but we'll try to find out the optimal solution using some kind of approximation. So that we made here in case of the soft computing techniques. So upset theory is also one kind of such soft computing technique, and which generally handle the imprecise data or inconsistent data. So whenever there are so many inconsistency or impreciseness is there in the data set, we generally try to apply the upset theory or the fuzzy theory. Though fuzzy theory we have applied most popularly, but upset theory is also important for many applications. And that upset theory concept was introduced by J. Pollock in 1982, and that is basically purely based on the mathematics, uncertainty mathematics, which is closely related to the fuzzy theory. And we can say that this fuzzy theory concept and the upset theory concept, that are actually the complementary generalization of the classical set. So what is the classical set or the traditional set? We know that set is the collection of well-defined objects. So for example, if we say that the set of integers in between, say 50 to 100, so this is the well-defined set, because if we consider another integer, any integer, say 70, we can say that yes, that belongs to that particular set. But if we consider, say 150, then this is not within this set. So that means any object we can precisely say whether that belongs to the set or does not belongs to the set. So that's why this is the concept of classical set or traditional crisp set, we say. But in case of the upset theory, so that type of solution we cannot find out easily. That means there are some objects that we cannot say that belongs to this set or not. So there is the possibility that belongs to the set or that may not belongs to the set. So that type of ambiguity is there. So in case of that type of data set, we generally use the concept of rough set. theory. So that type of set is called the rough set. And in case of the fuzzy theory, we know that individual object we consider, and we say that the membership value of this particular object in a particular set. Suppose one object may be there in 3 different sets with different membership values, say 0.7, 0.2, and 0.1. So by membership value or partial membership we use in case of the fuzzy theory, but there is the multiple membership value is there in case of the rough set theory. So rough set theory we define some different way than the fuzzy theory by the help of the approximation. Means the approximation, that means a set is corresponding, we compute different approximations. One is the lower approximation and another one is the upper approximation. So in terms of this lower approximation and upper approximation, we define a rough set. So we'll discuss this in details, how actually we can find out whether a set is the rough set or not. But how we use this in case of the knowledge discovery, as we know that in case of the any machine learning or say data mining techniques, these are the basic steps. For example, there will be the data set. The data set we may pre-process this data and we can find out the some pre-processed noise removal data set. After that type of pre-processing, we store this data in the database or some data warehouse, and then we may apply the feature selection algorithm to find out the important features or the features which are relevant to a particular application. So after selecting the features, that means we are actually reducing the data set. We are considering only the selected important features, and then we apply our say machine learning algorithm. So this is called the model construction algorithm. So this machine learning algorithm may be supervised or unsupervised algorithm. For example, that may be a clustering algorithm, that may be a classification algorithm, or some other say association rule mining or summarization algorithm and so on, or regression analysis we may have done using this the regression model, constructing the regression model. So there are different kinds of supervised or unsupervised algorithm we can apply on the pre-processed data set, and finally we find out the result, and also we measure the performance using different validate this constructed model and check whether the model that we have achieved is reliable or not. If this is not reliable, then again we modify different parameters or algorithms and repeat the same process. And when we are satisfied with this model, then we interpret the results, and then we store this result in terms of the knowledge. That means in case of some classification algorithm, we can say that different rules we are generated. So that type of rules we can store in terms of knowledge. So basically using these machine learning techniques from the database, we are generating the knowledge base. So database store the data and knowledge base store the knowledge or the different hidden patterns that exist among the data. So for that we apply the different steps, intermediate steps, including pre-processing, feature selection, and model construction, and so on. So that is the main steps. So we will check here how we can apply the rough set theory for the feature selection purpose and for the model construction purpose. So that we will discuss here within this slide. So now we will define the rough set theory. So basically we handle the uncertainty of the data set using this rough set theory that is developed by or introduced by the J. Pollock in 1982. And this rough set theory and also the fuzzy theory, these are the basis of the soft computing technique which was introduced by L.A. Jade. So we can say that these are the basis of the soft computing techniques. So using this rough set theory, that type of knowledge discovery purpose we can apply for characterization of the object set in terms of attribute values and finding dependency between the attributes, that is called the attribute dependency. And also we can check which attributes are the superfluous attributes. So actually the irrelevant attributes that we don't need for mining purpose or for learning purpose. So that also we can determine, and we can select the most significant attributes from the data set using this rough set theory. And also we can generate the decision rules by using the rough set theory based classification algorithm. So we'll cover these things. So how we can define then the rough set theory. So for that, any database, whenever we will consider, that we consider in terms of number of rows and columns. Individual rows are called the objects and individual columns are called the features. And the data set is called either information system or the decision system. For example, if we consider this one that contains A1, A2, A3, A4, these are the 4 attributes or features. These are called the conditional features, A1, A2, A3, and A4. And D is another type of feature that is called the decision feature or the decision variable, or we can say this is the class variable. So when decision is there, that data set is called the decision system. And if the attribute D is not there, then all the conditional attributes are there. That is called the information system. So decision system is a kind of information system. And when this decision system variable is there, then we use the supervised learning technique and like different classification algorithms. But if decision variable is not there, then we apply different clustering algorithm. So that is a kind of unsupervised learning technique, like different clustering algorithms like K-means, K-midweight, DB-scan, or different hierarchical algorithms and so on. So basically the decision system is defined in terms of, or information system is defined in terms of the order pair U and A, where U is the set of objects, universal set of objects. Here how many objects are there? This first row or second row is the first object. 1, 2, 3, 4, 5, 6, 7, 8 objects are there. So U is the set of all these 8 objects and A is the set of attributes. So information system we can define in this way. And so easily you can say that any attribute, say A, if we consider, that is a function or mapping that map from the object set or universal object set to the corresponding value. So that's why any attribute is a mapping from U to V of A. V of A means all possible values corresponding to attribute A. So okay, so that means information system is nothing but the like a table. Okay, so and the basic means terms depend, the rough set theory depends on which is the indiscernibility relation. So we have to know what is the indiscernibility relation. So indiscernibility means indistinguishability. So we will check here whether the objects are indistinguishable from each other or not. So that we have to find out. So here for each tuple if we consider, or each object if we consider, then we can check that whether there are 2 objects are similar or not. If they are similar, that means they are indiscernible. For example, if we check here, so this in this information system, how many objects are there? There are 10 different objects. And out of all these 10 objects, if we consider that the first and second object, object 1 and object 2, if we check, then they are similar. 1, 2, 0, 1, 1, 2, 0, 1. So 1, 1. So these 2 are the similar object. That means they are not distinguishable. So now we will check how we can find out in a large data set which are the indiscernible objects. So for that we have to apply the relation that is called the indiscernibility relation. So this is the kind of equivalence relation. So how we can define this indiscernibility relation? That is defined in terms of the order pair XY. So okay, so it is not. So if we check this one, okay, just a moment. If we consider the doc file, just a minute, please. So is the slide visible now? This slide?
Yes, sir.
Okay, so I will use this so that I can write something here. Okay, so if we consider this one, just you can check here. This is the indiscernibility relation, because we know that any relation from A to B, that means R is the subset of A cross B. So that is the, in discrete mathematics, so we have learned this, that we can define the relation in this way. So here U is the set where all the objects are there, O1, O2 up to O10. And so if you consider U cross U, that means we will get the order pairs, say object 1, object 2, object 1, object 3. So in this way we will find out all possible order pairs. So out of these order pairs, we will check how many order pairs corresponding to which the objects are same or similar. So in this way, if we consider object 1 and object 2, then all the values are same. So they are indistinguishable. So in this way, so definition is in this way, it is defined like this. So the order pair XY such that for all attribute A, its corresponding values for X and Y both are similar. So if this is X and if this is Y, so X of P1 and Y of P1, this is same. Similarly, X of P2 and Y of P2 also same. So in this way, for all the attributes, if we get the same values, then they are related with each other. So that's why for all attributes A, that must be satisfied, so that they are not distinguishable. So in this way, we can find out the all possible order pairs. So in every order pair, there are these type of objects where they are similar values or they are not distinguishable or indistinguishable. So that means based on this definition, we can say that this indiscernibility relation is an equivalence relation, because always object 1 is related to object 1. So that means this is reflexive. Similarly, if object 1 is related to object 2, that means object 2 is also related to object 1. So that is symmetric, and also it is transitive by this definition. So we can say that this relation is the equivalence relation. So in this way, we have find out all possible order pairs applying this relation. And since this is the equivalence relation, so that means always we can find out the partition, because we know that the equivalence relation always induces the partition. So partition means we can find out now different sets of objects where no common objects are there, and their union will give us the whole universal set U. So in this way, we have got here, these are the different partitions. O1, O2 will form one partition. O3, O7 and O10, just check here, O3, O7 and O10, say all values are similar. So that's why they are one equivalence class. In this way, we have got 1, 2, 3, 4, 5, 6, 7 equivalence classes. So depending on these 5 attributes. So now if we consider few number of attributes, so instead of all 5 attributes, if we consider only a single attribute, that is P1. So only this portion, this attribute we have considered. Then its corresponding, these are the different values. So now if we try to find out, so O1, O2, that will form one equivalence class. Similarly, O3, O5, O7, O9 and O10, they will form, that will form another equivalence class. And for value equal to 0, O4, O6 and O8, that will form another equivalence class. So if you consider 2 attributes or features, P1 and P2, that time we will get different equivalence classes. So based on the number of attributes we have selected, we will get different set of equivalence classes using this indiscernibility relation. So these equivalence classes means they are not separable from each other. They are exactly similar to each other. So within the set, they will appear all together. We cannot separate them from one another based on their properties or based on their feature values. So we will apply this term for defining the rough set. So how then we will define this? So after applying this concept of indiscernibility, we will check whether a set is the rough set or not. So for that, we will consider two different approximation set. One is the upper approximation set of X with respect to the feature set P, and another one is the lower approximation of the set X with respect to the feature set P by using this indiscernibility relation. And then we define the set X in terms of this upper approximation and lower approximation. And if these two approximations are same, then this set is called the crisp set. Otherwise, that is called the rough set. So our target is to define a set, whether it is a rough set or not. So we have to compute its lower approximation and upper approximation. So that we will compute using the indiscernibility relation. And this upper approximation and lower approximation is defined mathematically in this way, that lower approximation means set of all objects X such that its corresponding equivalence class is the subset of this set X. That means whether lower approximation will contain the object X or not, how we can determine? First, we have to check that element X belongs to which equivalent class. And if this equivalence class is the subset of the target set X that we want to determine whether it is a rough set or not, then that element will be there in the lower approximation. So basically, lower approximation is the set of objects which positively belongs to the target set. Means definitely belongs to the target set. But in case of upper approximation, we are not so much strict. So here we are checking whether this equivalent set may not be the subset of the target set, but possibly belongs to the target set. So how we can check whether possibility is there? So for that we check its equivalent set and the target set, is there any common element or not? If some elements are common, then we can say that yes, there is the possibility that that element belongs to the upper approximation set or target set. So we include this in the upper approximation set. So in this way, based on these two mathematical definitions, we will compute the lower approximation of a target set and upper approximation of a target set. So let's explain this with an example. So for example, suppose this is our information system or say decision system, where we are considering the attribute set P1 and P2 both are we have considered, and then based on these two attributes, by applying the indiscernibility relation, we are considering the equivalence classes. So O1 is 1, 2, and this is also 1, 2, so they will come together. Similarly, this is 2, 0, and here 2, 0 for O10. So O3, O7 also 2, 0, and O10 2, 0. So all they are one equivalence class. Similarly, we are getting O4 and O6 because they have 0, 0 and 0, 0. So in this way, we are getting different equivalence classes. So now, suppose you want to check whether the set of object X, which is equal to object 1, 2, and 3, whether this is the target set or not. So we are trying to find out this. So for that, we have to compute the lower approximation and upper approximation. So how we'll compute this? To compute this lower approximation set, first we consider object O1, and then we check what is its equivalence class. This is the O1 and O2. Since O1 and O2 totally belongs to this target set, that means they appear together here, so we can put here O1. So totally subset of this one. Similarly, For O2, if we consider O2, its corresponding equivalence class is O1A2, O1O2, so it is subset of this, so put here O2. But if we consider O3, its equivalence class is O3, O7 and O10, which is not subset of the target set. So that's why O3 will not come. So in this way, no other element will come within this lower approximation set. So it is positively belongs to this target set O1, O2 and O3, because O1, O2 is the subset of the target set X. So now for upper approximation, similarly, what we have to check for initially for object O1, its equivalence class is O1, O2. So O1, O2 is its equivalence class. So now, so it is the target set is O1, O2, O3. So some elements are common. So O1 will come here. Similarly, O2 will also come. But whether O3 will come or not, its corresponding equivalence class is O3, O7, O10. And if we check this with this target set, one element O3 is common. So that's why there is the possibility that that may be to the target set. So we are putting here O3 in the upper approximation. So by using the same logic, O7 and O10 will come to the upper approximation set. But if we consider O4, its equivalence class is O4 and O6. So no element is common with the target set. So O4 and O6, no one of these two objects will come into the upper approximation. So we can ignore this. So in this way, we can compute both the lower approximation and upper approximation. Okay, just a minute, I am just receiving one call. Hello. আমি ক্লাস নিচ্ছি এখন, আমি 5টার পর ফ্রি হবো, আমি ফোন করছি আপনাকে ক্লাসটা হয়ে গেল। ঠিক আছে, okay, sorry. So in this way we can compute the lower approximation and upper approximation. And now just check, lower approximation is this one and upper approximation is this one. They are not similar, so that's why the set is the rough set. And its corresponding what we can find out, this difference if we consider, that is called the boundary region. So that objects actually are the uncertain object, O3, O7 and O10. So just check here, O3 equal to 2, 0 and O7 also 2, 0 and O10 2, 0. So that is here, it's called the these three objects are called the in the boundary region. So in this way we can check whether any set X is the rough set or not. And if we determine the rough set, after that we can check what is its roughness. So for that we compute the accuracy value. Accuracy equal to number of objects in the lower approximation divided by number of objects in the upper approximation. So for the previous example, that value will be 2 by 5. That means 0.4. But in the worst case, the value will be totally 0, and in the best case, the value will be 1. And if the value is equal to 1, then we can say that this is the crisp set, because lower approximation and upper approximation is exactly exact or similar to each other. So that is the crisp set, and this case accuracy is equal to 1. And the lower the value means the set is more rough. And when the 0 value is there, that means all the objects are there in the boundary region. So that means, so if we consider the diagram, then we can check here that if this is the say this ellipse is the set, its corresponding lower approximation is the this portion, that is totally belongs to this or subset of this set, and upper approximation is the superset, so this portion. So what is the boundary region then? The boundary region is from lower to upper. So this portion, if any objects are there within this region, so they are called the boundary region. So that may contain some uncertainties, or some impreciseness or vagueness. So boundary region is there means some impreciseness or inconsistency is there. So we have to consider the consistent data, or we have to handle this boundary region to get the meaningful information. But for positive region, definitely we can get this information because that information is exact, so or certain. So we can use this for our knowledge mining technique. But for the objects which are in the boundary region, so we cannot apply directly this for our knowledge mining. So we may use some different techniques to extract some knowledge from these boundary region objects. So in this way, corresponding to a set, always we can find out the lower approximation and the upper approximation, and based on this one we can find out which one is the boundary region. And similarly, if we consider instead of a single set, if we consider say multiple number of sets, then for every set we will get the lower approximation and upper approximation. So if we consider the lower approximation for all sets, then we will get the union of the lower approximation, that is called the positive region. And similarly, if we ignore this or discard this from the universal set, then that portion is called the negative region. And the union of the upper approximation minus union of the lower approximation, that is called the boundary region that time. When instead of a single set, there is the collection of sets, say x1, x2 up to xn. Then for every set, you have to compute the lower approximation, upper approximation, and union of lower approximation is the positive region, and union of upper approximation minus union of lower approximation, that will give us the boundary region. And if we consider the union of this minus all this upper approximation, if we discard, then we'll get the negative region. That will be upper approximation, not the lower approximation. Union of upper approximation, if we discard this from universal set, then we'll get the negative region. So for example, that time this portion will be the negative region, this portion. So we can easily discard this. These are the negative regions, all the objects which are outside the upper approximation portion. So all these are the negative region objects. So you can discard them for our application. Okay, so now we will check how instead of a single set, if there are multiple number of sets, then how we can find out the positive region, negative region, and so on. So here, just for the same example, if we consider this is the data set or information system, and suppose we have considered instead of a single set X, we are considering here three different target set, x1, x2, and x1, x2, 0, 1, 2, x1. Oh, sorry, not this one. That is x1, x2, and x3. So why we are considering this as the target set? Based on the decision variable. Since decision variable, all these three values are same, and this one. So that means object 1, 2, 3, and 4. 1, 2, 3, and 10. So that is one target set, and another one is 4, 5, and 9. That is another set, that is x2, and remaining one, that means 6, 7, and 8. That is another target set. So if we consider these three target sets and then corresponding, so that actually totally give you the information system. So whether this information set or information system is the rough set or not, how we can determine them? For every set, we have to compute its lower approximation and upper approximation using the same formula that I have explained. So corresponding to the x1, the lower approximation and upper approximation is this. Corresponding to second one, x2, this one, lower and upper, and corresponding to x3, that is another lower and upper approximation set. So which one will be the positive region? Union of the lower approximations. So O1, O2, O5, O9, and O8 all will form together one positive region. So this is the positive region. Similarly, if we consider the union of upper approximation, we will get this. That is here for this example, that is U. So that means there is no means negative region. So negative region is here null. And boundary region is union of the upper approximation minus union of the lower approximation. That means 3, 4, 6, 7, and 10. So if we check now 3, this one, 2, 0, 0, and for 4, okay, for 7, if we check 2, 0, 2. So if we check this one, that object 3, its value 2 and 0, but its class value is 0. And in case of object 7, its value is also 2 and 0, but its class equal to 2. That means this is inconsistency, because though the same features are there, but they belong to different class. So that's why that is the example of inconsistency. So that's why that type of inconsistency arises here in the boundary region, because boundary region contains some uncertainty or inconsistency within the data. So that we have to handle. Either we have to delete one object out of these two, or we have to redefine the class of the one object. Instead of this is 2, we can say that will be 3 like this. So we have to take some other techniques, but these are the uncertain objects that we can determine in this way from the boundary region. And here in this case, the accuracy of the information system is 0.2. That means it is mostly it is rough. 0.2 means 20%, that is only exact, and 80% roughness is there. So many uncertainties is there in this data set. So this is the small data set, that's why we are getting like this. But in case of large data set, so that may be high or large depending on the values within this data set. So okay, so in this way we have considered the another example. So in this another example, what is there? If we check, so similarly we have considered here, and we check that the target set is different, and among that, if we consider, just check here, boundary region itself also the null. So boundary region is null means no inconsistency is there in this data set. So you can say that that is the crisp set. So all the objects set here, that O1, O2, O3, and O9, O10, if we consider, so this together and another this set. So considering all these sets, the information system, there is no inconsistency because the boundary region contains the null value. So no inconsistent or uncertain objects are there. So in this case, we can say that that contains the definite or certain information within this data set. So what actually we can say that corresponding to a data set, whether there exists some uncertainty or ambiguity or not, to determine this using rough set we can easily find out. So that we have discussed till now. And next we will discuss another term like indiscernibility relation, or like the rough set, different terms like lower approximation and upper approximation and so on. There is another term that is called the attribute dependency. So in this case, what actually we can say that how one set of attribute or one subset of attribute is dependent on the other set of attributes, how much they are dependent on each other. So that we can measure also using the rough set theory. So for that, what we have to do, just suppose P is the set of attribute and Q is another set of attribute, then corresponding to the set of attributes P, we will find out the indiscernible or equivalence classes. Similarly, corresponding to the set of attributes Q, we will get another equivalence set of classes. So then we will compare these two equivalence classes and check how they are dependent on each other. So now we will explain this one, and we define this dependency in this way that suppose we want to find out what is the dependency of Q on P. So dependency of Q on P is in this way we can define gamma of P on Q, where P is a single attribute or the subset of attribute and Q is the single attribute or a subset of attribute. So then we'll define dependency of P on Q. And if we write in this way, dependency of Q on P. So they may not be similar. This is the asymmetric. So they may not similar to each other. So how we will define this? So for that, there is the definition like this. So if you try to compute this gamma dependency of Q on P, then the definition is this one. So from this definition, what we can say, that just check here, L means lower approximation of the target set Q1 when P is the set of attributes. So what is Q1 then? Q1 is one equivalence class. So corresponding to the attribute set Q, we will get different equivalence classes. So these are say Q1, Q2 up to say Qn. Then corresponding to every Q1, Qi, we will compute the lower approximation and check how many objects are there within its summation. And divided by the total number of objects, that will give us the dependency value. So easily we can compute this. So we have explained this within this example. Suppose corresponding to this data set, one P each set of attributes A1, A4, and Q is the subset of attribute A2 and A3. So we check dependency of Q on P. So we check here dependency of A2 and A3 on A1 and A4. So that we will compute. So for that, first we have to compute the equivalence classes corresponding to P and also corresponding to Q. So corresponding to P means A1, A4. If we compute A1 and A4, that is M, and so that is only O1. And similarly, if we consider this one O5, that is also M. So O1 and O5, they are in a single class. So that is one equivalence class. Similarly, O2 is separate one, no common with other. And similarly, if you consider O3, O4, O3 is L, that is M, and O4 also L, M. So O3 and O4 in another class, another equivalence class. Similarly, O7, O8, another equivalence class. So in this way, we are getting 1, 2, 3, 4, and 5 equivalence classes corresponding to P. Similarly, corresponding to Q, if we consider A2 and A3 for this one, if we consider, then check here L and 3, there is no other L and 3. But if we consider O2 and O3, for O2 L1 and for O3 also L1. So O2 and O3 is one equivalence class. So in this way, 4, 6, and 7. So 4, 6, and 7, same values R3, R3, and R3. So they are another equivalence class. So in this way, here also we are getting 1, 2, 3, 4, and 5 equivalence classes. So now actually what we have to identify that these equivalence classes and these equivalence classes are similar or not, or how much they are similar. Based on this one, we can say how much they are dependent, P and Q. So for that, definition is this one. So what actually you can do for every dependency of Q, that means this is the target set Q. So this is Q1, this is Q2, Q3, Q4, and Q5. Corresponding to Q approximation, corresponding to Q2, compute lower approximation. Similarly, corresponding to Q5 also compute lower approximation. And take the union of all these lower approximation, that will give you the positive region, number of objects. So there is no any element there. All the lower approximation region is the null set. So that's why 0 number of elements are there. So dependency value equal to 0. So they are no dependent on each other. There are no similarities there. So that's why we can say that attributes, that means attributes set Q means A2, A3 is not dependent on A1, A4. That means they are independent on each other. So these elements are independent on each other. In this way, we can measure the dependency among any subset of attributes or any single attribute. So now, suppose we are considering the one as the decision variable. So since decision variable is there, that means this is the target. This Q1, so now check here, O1, O2, O3 is one equivalence class. Similarly, 4, 5 is another equivalence class, and last 3, all 3 values are there. So that's why that is 6, 7, and 8. This is another equivalence class. So now we try to find out dependency of Q means D decision on A3, A4. So that we want to measure. So A3, A4 is here P, and its equivalence class is this one. So now what we have to compute, that for every equivalence class corresponding to D, we consider lower approximation, lower approximation. So in this way, if we consider the lower approximation, then we get for Q1 there are 2 values, for Q2 there is 1 value, and so on. So if we take the union of these, how many objects will be there? 2, 3, 5, 6, 7, 8. That's 6 attributes. So what will be the dependency then? That 6 attributes will be positively belongs to the target set, means within the lower approximation set or positive region, means certain objects are there. So out of all 8, 6 objects are there in the positive region. So that's why that dependency value is 6 divided by total number of objects U. So that is 0.75. So in this way, you can say that highly dependent, the decision attribute is highly dependent on these two, A3 and A4, but not fully dependent. That means there may be some other attributes. Combining this, we can get more dependency. So that is quite natural, because in case of any, for example, suppose in selection process, so this is the decision variable, either selected or not, the employee selected or not for a job. So in this case, these are the different features based on which we have selected. So we have to check our selection depends on which criteria. So we can say that our selection depends on A3 and A4 75%, not fully dependent, not 100%. So in this way, we can check when decision variable is given, we can easily compute the dependency of this decision variable on some subset of the conditional variables. So in this way, we can find out dependency of any one variable on the other variables. So that is very much important in case of many purpose. For example, suppose if we get this value equal to 1.0. So that means what we can say, that target value decision variable D fully dependent on A3, A4. So that time we don't need to consider A1 and A2. So that time we can say that A1 and A2, they are superfluous attribute or irrelevant attribute, we can discard them. Only A3 and A4 we can consider as the important features. So based on this one only, we can select the important features also. So in this way, that is the importance of the attribute dependency. And if two attributes are independent on each other, so that means we cannot ignore them. But if one attribute is fully dependent on another one, so any one we can consider and we can ignore the other one. So in this way, so many decisions we can take based on the attribute dependency. And as I told you that that is very much important for determine whether the important features are important or not. And so that attribute dependency concept we can use for feature selection purpose. And in case of the upset theory, the important subset of features that will be selected, that is called the reduct set. So that's why in terms of upset theory, that is called the reduct set or minimum subset of features. So that is called the reduct. And this reduct generation algorithm is called the quick reduct generation algorithm. So what is the definition of the reduct in case of the upset theory? So that we will define now. So basically this is, we know now, this is the equivalence classes. So using this reduct, that means if A3 and A4, if we consider this as the reduct, then its corresponding equivalence class we have to check, and that will give the whole equivalence class if we consider the whole subset attribute P. Suppose P equal to all the attributes P1, P2, P3 and P4. So its corresponding equivalence classes if it is exactly similar to the equivalence classes corresponding to the reduct, means A2, A3 and A4, then we can say that A3 and A4 is the reduct. The same set of equivalence classes will be obtained. And not only this one, but this one will be the minimum number of features. That means if we remove anyone from the reduct, so from this reduct set A3 and A4, if we remove anyone, then that set of equivalence class will not similar to that set of equivalence class. So that is the minimality condition. So if both the conditions are satisfied, then we say that this set is the reduct set. So we have to determine actually this one. So we have to find out the minimum set of attributes for which the same equivalence class obtained. And if we remove anyone, then that condition will be violated. So then this minimum set of attributes is called the reduct. That we have to find out. And this reduct is not unique. So there may be many possible number of reducts corresponding to a decision system. And if there are multiple number of reducts, then their intersection, if we consider, that means that is called the core object or the most important object. So actually this core attribute is the necessary attribute, and the reduct set of attribute is the sufficient set of attributes. So we cannot ignore this core attribute. So that's why this is most important attribute. And this core also may be empty. So if there is no element common in several reduct, then the core must be empty. So now actually we will check how we can find out this reduct using different algorithms. So that we will discuss. So before that, we will explain here using the discernibility matrix. We will check which attributes are means importance and what is their priority of or the order of importance. That suppose we want to find out which one is the most important attribute, which one is the next most important attribute, and so on. So using this simple matrix, we can easily compute. So how we can compute this? So these are nothing but some data mining purpose. Actually, we are data we are extracting which one is the most important attribute. So most important attribute, we say that this is the core attribute. So we'll check whether there exists any core attribute or not for this decision system. So for that, how actually we can find out this? So very simple logic is that suppose the decision class here, these are all of same class, these two of another class, and these three of another class. So there are three different classes within this set of objects. So now we are trying to find out by which features we can distinguish them. This by out of all these four features, by which features we can distinguish. Actually, object 1 and object 2, object 3, this is object 4. Object 1 and object 4, they are not same class, because one is of class 1 and another of class 2. But now we'll check by which conditional feature we can distinguish them. So that we have to find out. So in this way, that's why we are considering one matrix or discernibility matrix whose dimension will be, say, number of objects here 3, 3, 6, 8. So that matrix will be of 8 cross 8 matrix. If there are m number of objects, then that dimension will be m cross m. For every pair of objects, we have to check by which attribute they are different. So if we consider object 1 and object 1, since they are similar, so we don't need to compute this. Similarly, for object 1 and object 2, since they are of same class, so we don't need to compute them. So for object 1 and object 3, they are also same class, one class, so we don't need to compute them. But object 1 and object 4, if we consider, they are of two different classes. That means they are of different sets. So by which then they are different, that we will check. If we check O4, then the same O4 is there. That is also M, that is also M. So by this one, they are not distinguishable. But if we consider A3, yes, they are also same. So they are not distinguishable. But if you consider A2, then A2 value is L, and for this one, this is R. So they are distinguishable by A2. Similarly, they are distinguishable by A1, different values. So we can say that by A1 and A2, they are distinguishable. So object 1 is distinguishable from object 4 by two attributes, A1 and A2. So that's why these two objects features are here. So similarly, if you consider object 1 and object 5, they are distinguishable by this one. So in this way, you have to compute all possible values. So for example, if you consider object 1, 2, 3, this is object 4. Object 4, and this is object 6. Suppose we want to compute this one. So how we get this? So consider object 4 and object 6. Object 4 means 1, 2, 3, 4, this one. This is of class 2, and object 6 of class 3. So they are different. So by which attribute they are different? So if you consider this one, M, this is M and this is L. So they are different. By A4 they are distinguishable. But if you consider other things, this is 3, this is also 3. This is R, they are also R. This is L, this is also L. So all other values are same. Only A4 value is different. So by A4, we can distinguish object 4 and object 6. So if we, after construction of this matrix, what we can say, for any entry, if you consider, suppose for example, we are considering this one. Then what we can say? We can say that object 3 is distinguishable from object 7 by all 4 attributes, A1, A2, A3, and A4. So if we consider only A1, then also we can distinguish object 3 and object 7. So out of all 4, by any one attribute, we can distinguish object 3 and object 7. So you can ignore 3 and only consider any one. But here, if we consider in this entry, there is only one attribute. So if we consider object 4 and object 6, they are distinguishable only by A4. So we cannot ignore A4. But here we can ignore A2, we can ignore A3, we can ignore A4. Any one we can consider. We can ignore all other 3. But here only one value is there and we cannot ignore this. So that's why this is most important attribute. Because if we ignore this A4, then we cannot distinguish object 4 from object 6. But object 4 is already separate from object 6 because they are of different classes. But if we ignore A4, then we cannot distinguish them. So that's why A4 is most important. So within this entry, what we can say, if any entry contains only one attribute, so that one is the most important attribute. If there are also here, suppose A2 is there, then also obviously A2 is the most important attribute. So in this way, you can find out from the decision matrix which one is the most important attribute. So that one we can consider as the core attribute. Since all these are the approximations, means kind of no real-time solution you are finding, so that this is a kind of a heuristic you are applying. So this is one logic by which you can say that A4 is the most important attribute or core attribute. And similarly, another type of decision we can take, suppose you want to find out from this one, okay, A4 is the core attribute. Now, for the other attributes, which one is the next important attribute and next to next important attribute and so on. So you can apply your own heuristic here. Suppose we are using here that consider the frequency of every attribute. That means for making the separation between the pair of objects, which attribute appears more number of times, then we can say that that attribute is the most important attribute. So in this way, if you consider, then you have to measure the frequency. A1 appears how many times, A2 appear how many times, A4 appear how many times, and so on. So in this way, you can measure the frequency, and also we can use this. So we'll discuss this one after discussing this algorithm. So this algorithm actually is called the quick reduct algorithm or a kind of feature selection algorithm. So this is very popular and very simple feature selection algorithm for upset theory based on this lower approximation. Lower approximation means we have to use the indiscernibility relation. So how we can compute this feature set? Initially the reduct set is null, and it is null, and then for all the features x belongs to this feature set, we check the dependency value. Dependency of the decision variable on this reduct union x means null union x means x. So first we will compute gamma x corresponding to d, and also we check gamma d corresponding to t. T is initially empty, so in this case initially just consider the null value as a 0 value. So you will get some value here, attribute dependency value. Then if we get the dependency value more than this, then add this in the reduct, and after that repeat the same process, consider the next value. Suppose for a1 you have got, then consider a2. So now you have here a1 and a2, and here only a1. So if dependency more, then you add a2. Suppose you have got a1 a2, and then suppose you are considering another one, say a3. So in this case that will be a1 a2 a3, and here that will be a1 a2. And if it is not greater than, so not more number of objects are there in the positive region, so you can ignore this a3. So you just ignore a3 and consider again a4. So now consider a4. So in this case that will be a1 a2 a4, that is a1 a2. And if it is more, then again add a4. And if it is not there, then ignore this. So in this way, after repeating this algorithm, again check whether this dependency condition is satisfied or not. This is corresponding to whole set gamma d of c, that is for the whole attributes, all the attributes. So if this dependency is greater than or say equal to, then terminate the process. Otherwise again repeat the process and consider the next attributes and repeat this. So basically there is the nested loop here. So by this nested loop, actually you are getting this reduct set in set of important features. So that is how simple this process is, that only the two loops are there. One repeat until loop and another one is the for loop. Using these two loops only, you can find out the important features. So this is one heuristic or approximation algorithm, and that in many cases that gives very good result. So we have explained this with this example here. Okay, suppose here, just check here, if we consider the whole set means a1 a2 a3 and a4, and then if we consider that dependency value gamma d of c, so that computed here is equal to 1. So according to the algorithm, until the value is greater than or is equal to 1, we are repeating the process. So now we'll check how actually we repeat this process now. So initially just using this dependency, as you know, gamma value we have computed. For every target set, we have to compute the lower approximation and take the union and divided by total number of objects, that is equal to 1 here. So that value is equal to 1. So now we'll check the quick reduct algorithm, how it works. So let's start from here. So initially we know that there are 4 different attributes, a1 a2 a3 and a4. So according to the algorithm, reduct is null, t is null. So what is c minus reduct here? What is c minus reduct? That will be equal to all the attributes. And then for all the attributes, you have to repeat this. For all x belongs to this, so initially consider say x equal to a1. So consider x equal to a1. And then based on this algorithm, what will be the value? Gamma of null union a1. So gamma of a1. So for a1 you have to consider. So corresponding to a1, you compute the equivalence classes, the value m for object 1, 2, 5. So they are together. In this way, you get the equivalence classes. And corresponding to decision, the equivalence class is this one: 1, 0, 2, 3, then 4, 5, and then 6, 7, 8. So now corresponding to every decision equivalence class, say 1, 0, 2, 3, compute the lower approximation. Similarly for 04, 05, compute the lower approximation, and 06, 07, 08, compute the lower approximation. Then you get total, you will get 2 different objects. So the dependency will be 2 by 8. And this is initially greater than 0. That's why you select this A1. X equal to here A1. So C1, A1 is selected. So after selecting A1, what are the, in this inner loop, what are the remaining objects? Then A2, A3, and A4. So consider now A2. So now you have A1 and A2 here. So corresponding to A1, A2, this is ML, this is ML. So O1, O2 will be there together. Similarly, O4 and O6, if you consider LR and LR. So that is another equivalence class, O4 and O6, and all other different values. So these are the equivalence classes. But decision corresponding equivalence class, that is same. So now compute again corresponding to D1, D2, and D3, compute the lower approximation and check number of objects equal to 6. So accuracy will be 6 by 8, which is greater than this 2 by 8, previous one. Previous 2 by 8 was there. So greater than, so according to this one, you take the union. So A2 will be selected. So now in your reduct set, how many selected attributes are there? A1 and A2. So repeat the next iteration, then A3 will be selected. So after selecting A3, the equivalence classes will be this one, and the number of objects the same. So it is not increasing, so you don't need to select this. So A3 is not selected. So now you select A4. So after selecting A4, we will get 8 by 8 means 1. So it is greater than 6 by 8. So A4 is selected. So A4 is selected means now one iteration is complete, inner loop is complete. So now we have selected A1, A2, and A4. So now you just check this until condition, that value is greater than this. So that is exactly equal. So it is not greater than. Actually, that will be greater than equal to. So you don't need to repeat this. Or if it is greater than, since it is not greater than, you can repeat once more. So whenever you will try to repeat this one, so only A4 will be selected. So no improvement will be observed. So terminate the process. So basically, after applying this algorithm, so that inner loop first time it will repeat for 4 times for first time of the outer loop, and for the second time it will apply once, and then third times this condition violates and exit. So basically total only 5 times this inner loop will execute, and by that we can determine that A1, A2, and A4, this is the reduct. And so this is the quick reduct algorithm, how it works. And now if we try to modify this, that initially we have considered the reduct equal to null. Suppose from the definition of the core, what we have considered, this is the necessary attribute. So if we determine the core value by the previous matrix form, we have determined that A4 is the core attribute. From this discernibility matrix, decision matrix, what we have decided before few slides, that A4 is the core attribute. And also I have told you that for the other attributes, based on their frequency, suppose these are the frequencies, 17 times, 15 times, and 14 times occurs. So more times occur means more important this one. So based on this, A2 will be next important, then A1, and then A3. Suppose you have arranged the objects in this way. So now if we check, initially if we now apply the quick reduct algorithm, by initially instead of reduct equal to null, initially we say reduct equal to A4. And the remaining objects we consider in this order. First A2, then A1, then say A3. So though it will not work for all the data set, But for this data set, we can check that it will give you more appropriate result. So how? Just we will check here. So in this case, corresponding to the core attribute only, the dependency value equal to 0.5. So initially we said gamma value equal to 0.5 instead of 0.0. Then if we consider the same algorithm, so now we will consider first A2, and corresponding to A2, directly we get the dependency value equal to 1, which is greater than 0.5. So A2 is selected. And then for other attributes A1 and A3, you will not get more value, so not selected. So finally we are getting only A4 and A2. So A2 and A4 will be the reduct. So initially we have got A1, A2 and A4. A1, A2 and A4. Now we are getting A2 and A4. Just check here, one attribute is more here, but it is not here. And so more number of features are there. Since we have started from A1, that's why it comes. But if we started from other attribute, then it may not come. So that's why it may contain some spurious or some irrelevant attribute also, because we don't know from which attribute we will start. Once the attribute will be selected, there is no option to remove this attribute in this quick reduct algorithm. So that's why this is one demerit. It may contain some spurious attribute. Since generally the feature selection algorithm consists of incremental selection and backward removal, but this removal is not done here. So that's why that may contain some irrelevant attribute. But here, if we modify the algorithm in this way, then we say that A2 and A4, this is the minimum subset of features by which the same equivalence classes we have achieved. And so this is the kind of feature selection algorithm. So after that, that means how the feature selection algorithm reduces the data. So if we consider, suppose this algorithm and A2 and A4 we get, then we can modify the data set in this way that instead of A1, A2, A3, A4, we can consider only A2 and A4, and the decision attribute will be there, D. So now this is A2 and A4, so L, M will be there. Next one will be L, H will be there, and so on. So just check here, two attributes or features corresponding column A1 and A3 we don't need. So dimensionality is reduced and corresponding volume of the data set is also reduced. So we now consider this reduced data set for our learning purpose, for applying the different supervised or unsupervised learning algorithms. So we will now check how this reduced data set we can apply for our classification algorithm, or say rule generation algorithm. So that now we will discuss. So because you know that supervised learning is very much important, not only for categorization of the existing data set, but also we may use this type of data set for unknown class labels, because based on some rules or some other rule-based classification or some other classification algorithm, once the model is trained, then we can label the unknown samples also based on the trained model. So that is the main objective for any supervised learning algorithm. So here, using this concept of rough set theory, we first reduce the data set by generating the quick reduct, and after that we'll check how the classification algorithm is learned for generating the some set of rules. So here we use this type of notation, that if there are, say, this type of attributes, say A1, A2, A3 and so on. So A1A, that means A1 is equal to A. A2B, that means A2 is equal to B, and so on. Then the class value D equal to D. So we can define the rule in this way or in this way. Okay, so now how we will generate the rules or train the model, so that we will discuss. That is developed in a paper published in 1995 by 𝐃𝐞𝐩𝐚𝐫 and son, by generating the decision matrix. So we know that there are some other classification algorithms like decision tree algorithm or some say naive-based classification algorithm and so on. So similarly, this is another kind of rule-based classification based on the decision matrix. So that algorithm is very simple, and how it works, just we will explain now this one. Suppose this is our initial data set, and after applying the rough set theory, we get A2 and A4 as the reduced set, and so the reduced data set is this one. Just check here, not only the dimensionality is reduced, but here 8 objects was there, but here only 5 objects, because other 3 objects are same to any one of objects. Say LM is there, similarly LM for A2 and A4, say MM is there, object 1. This one is object 1, 2, 3, 4, 5. Object 1 and object 5 similar if we consider only A2 and A4. So in this way, some objects will be means duplicate. So you can remove this. So in this way, both vertically and horizontally, the data set will be reduced. So now, suppose we have this data set, and we will try to generate the rule set from this data set. So how we will generate this? So the decision matrix based rule based algorithm means the steps are like this. Since there are 3 different classes, first we consider the class value d is equal to 1 and check which are the objects corresponding to d is equal to 1. These are object 1 and object 2. And now check which are d not is equal to 1. Means all other objects are d not equal to 1. That means object 3, object 4, and object 5. So now for d is equal to 1, the objects, put them in the row, and for d not is equal to 1, the objects, put them in the column. Because they are of different classes, so now try to check O1 is different from O3 by which features. So for O1, O3, similarly for O1, O4, and for O1, O5. Similarly for O2, O3, O2, O4, and O2, O5. We'll check. So for O1 and O3, if we check, this is O1 and this is O3. So the same, these are 2 different values, L and R. And here they are same values, M and M. So only by this one they are different. So that's why A2 value. So consider here A2. And in subscript we put L because value of O1 is L. Object O1 value is L. So we are putting here A2L. That means A2 is equal to L. So by A2 is equal to L, you can say that object 1 is separable from object 3 or distinguishable from object 3. Similarly, if we consider object 1 and object 5, so this is object 5. So L, N, so 2 different values. Here M, L, that is also different values. So object 1 means A2L and A4M. So A2L and A4M. By these 2 attributes, this object O1 is different from object O5. Okay, so now just think here, what is our target? Our target is to separate these 2 objects from these 3 objects. So if you consider only this object 1 is separable from object 3 by this, object 4 by this, and object 5 by this. So you can say that object 1 is separable from these objects by this and this and this. So we can say that that is separable by this from object A2L, and second one is A2L, or you can apply plus A4M. Either this or this, by anyone you can separate. Similarly, and for next one, A2L or A4M. So by this expression, we can say that object 1, which is of class D is equal to 1, is distinguishable from all the objects which are of class D not equal to 1. Similarly, for object 2, we can say that object 1 O2, which is of class D is equal to 1, is separable from all the objects which are of class D not equal to 1 by this or this, and this or this, and this or this. So if we consider these two expressions, by these two expressions we can separate any object of class D is equal to 1 from any object of class D not is equal to 1. So that means we are getting two different Boolean expressions. So these two expressions, if we consider this type of values like A2L equal to X, A4M equal to Y, and so on, then we will get this expression and this expression. So that is by minimizing, we get this is X or this, and this one after minimization we get X plus Z, that is equal to this. So what you can say, how many rules we are getting? That if A2 is equal to L, then class D is equal to 1, because we are constructing this for class D is equal to 1. And from second one, what we can say, if A2 is equal to L or A4 equal to H, then D is equal to 1. So these are the rules corresponding to class D is equal to 1. But in the data set, there are another two classes. So similarly, for class D is equal to 2, we have to construct this type of expressions with the help of decision matrix. So here again, for D is equal to 2, only one object will be there, O3. So O3 in the row, and all other objects will be in the column. So we are getting this, and from this one we'll get the expression like this, and after minimization we'll get this one. So that will provide us another rule. If A2 is equal to R and A4 is equal to M, then D is equal to 2, because this is for decision equal to 2. So now in the data set there is another class, that is D equal to 3. Similarly, for D equal to 3, we will get object 4 and 5. So there will be the row, and other objects will be in the column. Then we will get two different expressions. Again, we will minimize this, and we will get different rules. For first one, A4 equal to L, then D equal to 3. For second one, A2 equal to N or A4 equal to L, then D equal to 3. So as a whole, what we can say, that possible number of rules generated, that is equal to this, this, and this. So if you consider these 5 rules, then what will be the accuracy of the model? So training accuracy we are considering, because this data set is used for training purpose or for this rule generation purpose. And after that, if we measure the accuracy, then we check that for all the objects it is correctly predicted. So that means 100% accuracy is there. And as we have discussed the quick deduct generation algorithm, that give us 3 different attributes, A1, A2, and A4. So if we apply this same decision matrix concept for rule generation, then similarly if we apply D equal to, for D equal to 1, for D equal to 2, and for D equal to 3, then for D equal to 3, then we will get these many rules. Sorry, these many rules. By considering 3 attributes for A1, A2, and A4, we are getting these rules. So now if we compare them, just check here. If we compare now, whenever we are considering only here A1, A2, and A4, then we are getting that many rules. And if we consider the modified rules, A2 and A4 for features, then we are getting that many rules. So now check this one and this one, they are extra rules here, because some extra features are there. So that's why some extra rules will appear. Okay, but other rules are, all other rules are same. So in this way, what actually you can say, that based on the feature set, selected feature set, we can find out different set of rules. And but both here are providing the 100% accuracies. But the important is that not for the training data set. If we consider the test data set and check the accuracy, suppose this one will provide you the 90% accuracy, and that one will provide you say 75% accuracy, then you can say that though there is one extra features, but this rule set is more important, because for test data set it is providing more accuracy. So in this way we can check, though we have applied some modification here, whether that modification will give us better result in terms of the performance of the model or not. So if it is not providing this, then we have to sacrifice that. Yes, we can consider 2-3 more features, since our main target is to find out more accuracy. So that time we should consider this feature subset instead of considering this feature subset. But in terms of the accuracy or some other measures, if we get better result for the reduced data set, then obviously it is advantageous that we are reducing the features, and at the same time our models will perform better also. So that we have to analyze the results to decide or to validate our method. So what we have discussed till now for this knowledge discovery purpose, that we have used the rough set theory for feature selection, and also we have generate one model for classification or rule-based model, and then we have to validate this model or model validation. So how we will validate this? So for that there are different steps. Like first we have to measure the performances and test accuracy also, and also we have to compare with some same type of models which are already exist, and based on all these things you have to validate, and until your model is validated, then you have to modify the previous steps. So that's why model validation is very much important. So any model you have proposed and you can say that it is the very good model, so that is not acceptable by the others. So that's why you have to validate the models. And to validate the models, what we have to consider, that after construction, based on the training data set, now we have to consider the test data set, and based on the test data set you have to evaluate the model, or and if evaluation gives the better accuracy, then only we can use this model and predict the unknown class level for prediction purpose. First we have to evaluate the model. So the data set will be split into training data set and test data set, and that based on the training data set we have to learn the model, and then we get the classification model, and then apply this model for the test data set, and then check, evaluate its performance. What is the test accuracy or test other performance like precision, recall, and so on. So that we have to measure. So that we will discuss now, how we can measure the performance corresponding to the test data set. Okay, so for this, what we can check, that there are different terms. Like if we consider this a binary class data set, that means it has two class data. One is say d is equal to 1 and another one is d not equal to 1. So this is the negative class consider, and this is a positive class. Any one you consider as negative class and another one you can consider as the positive class. And now suppose you plot all the objects here within this space, and now suppose this straight line, this is your classification model that we have trained after training of the model based on the training data set. Suppose this is our classification model. Suppose this is the linear classifier. So now just if we check here, all the red mark dot if we consider as the positive class, and all the black dots consider as the negative class. So now check here, if we consider this black dot here, given here and here, so though they are negative class, but they are going to the positive side of the classifier. So they are basically wrongly predicted as positive class. So that's why these objects are false positive, or that is called FP. Similarly, if you consider these red class, these are the positive classes and they lie also in the positive side, the same side. So they are called true positive. And if you go to the left side, here these red objects here, so they are basically of positive object, but they belong to the negative side falsely. So they are false negative. So these are called false negative object. And the dot in the left side, they are all negative class and they lie also this same side. So they are called the true negative. So based on the classifier, if we consider test data set, then corresponding to the test data set, always we can compute how many objects are false positive, how many objects are true positive, how many objects are false negative, and how many objects are true negative. And the sum of all these is equal to total number of objects. So that value we can store in a matrix that is called the confusion matrix. And this confusion matrix gives us the true positive, false negative, false positive, and true negative values. And based on this confusion matrix values, we can measure this performance matrix. These are accuracy, precision, recall, and F-score. So suppose, for example, for a data set, suppose one disease data set is there, some particular say cancer data. So in this case, accuracy is almost say 98%. Okay, so in this case, so out of say 1,000 objects, 98% means 980 objects are correctly predicted and 120 objects are wrongly predicted. So in this case, suppose these wrongly predicted, all the samples are of suppose negative class, positive class. That means cancer data, cancerous sample, and these are the normal samples. Suppose all the normal samples are correctly predicted, but no cancer samples are correctly predicted. So though the accuracy is very high, but the other measures are accuracy is very high, but we cannot rely on this model because it cannot predict the cancer samples correctly. So that's why accuracy is not only the performance metric for model validation. So that's why at the same time we have to consider the precision, recall, and F-score. F-score is the harmonic mean of both precision and recall. So if we now consider the precision value and recall value, so now you can check out of this what is the precision value, that is false positive value is there, falsely positive. The negative value, that means though it is cancers, it is saying that falsely it is positive. Means, and for recall, falsely negative, though it is positive. Positive means cancer data is there, but it is saying that no, it is the normal sample. So this is more dangerous. The false negative value is there means falsely it is saying that this is the normal sample, but it is actually the cancerous sample. So that's why, so that value actually you have to consider. In ideal case, Fp is equal to 0 and Fn equal to 0. Then precision value will be equal to 1 and recall value will be equal to 1 and F-score value will be equal to 1. But that type of correct model generally is not available, that for all the data set that will give you the 100% precision, recall, and F-score values. That's why we need to compare different models with your proposed model, and we have to check what is the accuracy, precision, recall, and so on. And if overall it is giving the satisfactory result, or if you rank all the say 10 models and say that for the data set your overall rank is say 2.3 or like this, then also you can say that we can rely on this one. So these are the different performance measurement criteria. Except this, there are other kinds of statistical measurements like say chi-square test and different parametric tests like t-test, or say Wilcoxon rank sum test, or other different statistical tests are there. And also there is the say you can generate the ROC curve and check what is the area under the curve. Area under the curve is maximum, means the classifier is the better one. So there are nowadays many tools are available. We can apply these tools to measure this type of ROC or area under the curve value, or you can draw the ROC curve and so on. And based on all these type of probabilistic and statistical measures, you can compare with other models and you can validate your proposed model. Okay, so this is the comparison or for validation purpose. And at the same time, there is another important things, as I have told you, that the data set you have to split for training and testing purpose. So that type of splitting is possible in different ways. So one of the method is called the holdout method. So in case of holdout method, what we do, select randomly 60% objects for training set and remaining 40% for test set. But since we are randomly selecting this, so the different class objects may not come in well distributed way. So so the training and testing objects may not be well distributed in this case. So that time some biasness may be there. So we generally use the cross validation technique. If the data set is very high, then we consider the 10-fold cross validation. And if for low volume of data set, we may consider 3-fold or 5-fold cross validation. The logic is this: we divide this or partition this into, for 3-fold cross validation, 3 different folds. And in the first iteration, first fold considered as the test data set, and second and third considered as the training data set. This is fold 1, this is fold 2, and this is fold 3. So in the second iteration, first one and third one considered as the training, and fold 2 considered as the test purpose. And in the third fold, fold 1, fold 2 considered as the training, and fold 3 considered the testing purpose. So now check, if we consider this, then every data set, for the first one, fold 1 will be the testing purpose, here second one will be the testing purpose, and here third fold will be for the testing purpose. So every object is used for testing purpose. So that is important here, that we are testing our model by each and every object, so by this validation technique. So and if we consider the overall testing accuracy or overall testing precision, we call it measure and so on, based on this one we can compare the method with other methods. So in this way, validation, cross validation is also very much important techniques. And except this, one demerit is that though we have considered the data set, generally there are many data set for which the data set is not balanced data set. Possibly for simple sample disease data set, some are disease data set, like say positive or cancer data, and many are normal data. So this type of problem is called the class imbalance problem. So for this class imbalance problem, you may not get so much good testing accuracy for the data set. And in this case, we have to balance the data set. So that is another research area. So how we can balance the data set by different techniques. So nowadays there are many so it says sampling, undersampling, oversampling techniques are there. Or in case of deep neural network, we know GAN is one of the popular deep neural network techniques by which we can generate some duplicate data also. So in this way, we can make the data set balanced, and then we can apply our proposed model also. So that is another direction for learning machine learning techniques. And so as a conclusion, we can say that yeah, the rough set theory is a very important soft computing technique where we don't need any prior knowledge. It is a simple handle the simple uncertainty mathematics, and the only requirement is that the data must be in the discrete form. So some important discretization algorithms we have to apply, otherwise we'll lose the information. So we have to check this one. And but whenever the data set is properly discretized, then we can use this for many kinds of knowledge discovery techniques, including clustering, classification, or feature selection. Also, we can find out the dependency among the set of attributes. Also, you can find out the important attribute, core attribute, and deduct attributes, and so on. So, but there may be many different concepts that we can use for exploring the boundary region, and that time also we can combinedly we can use the rough fuzzy concept also there together to handle the uncertainty mathematics also there. So as a whole, though there are many demerits, but for many applications where a lot of uncertainty is there, the rough set theory and the rough set and the combination of the fuzzy set theory may be very much useful. So we can apply this for our many different applications, and we can mining or extract different knowledge from the data set. So that's all. So thank you very much for listening this.
Yeah, participants, if you have any question, you can ask. And Asit sir is really a strong researcher in rough set theory. Actually, all his publication and research works are mainly focusing on this domain, and very strong research scholars is working with him. So whatever the queries are related, you can ask. Asit sir, really impressive presentation.
Yeah, thank you, sir. Thank you.
Especially in point of adding the notation and symbols and explaining is really a good thing. So that is the main flavor of your presentation. We really enjoyed it. So any participants, if you have queries, you can ask. Yeah, I think everybody has received the information we have discussed. So
Yeah,
really,
yeah. In any time, if they ask, then I can give the answer also.
yes,
to the mail.
definitely.
And actually, there are so many mathematics are there. So
Yes.
to memorizing all these things and asking different questions is sometimes it is difficult. But if
Yes.
you study this and ask any question anytime, then I will try my best to give the answer.
Definitely. So thanks a lot for the nice presentation, sir. And sparing the time in your busy schedule is really a great thing for today. So we have almost all the participants has received the information you have conveyed. Really a wonderful presentation, and sparing the time. As you suggested, mathematical modeling is the main agenda for a research work. And also for faculty point of view, the core area should be touching the mathematical knowledge will be taking forward to the next level of concept understanding. So that is the real flavor, and you have given such a nice thing in that insight of this topic. Thanks a lot, Asit sir. Thanks for sparing your time.
Thank you very much, and thank you to Bimal sir also for inviting me for this presentation purpose.
Yes. Thanks a lot. Thank you, sir.
Okay,
Thank you
thank
very
you,
much.
sir.
We will keep
Thank
in
you very
touch.
much.
Thank you very much.
Okay.
Participants, we will post the feedback now. Yes, it is posted. So you can submit your feedback, and all the feedback link we will be posting in the session only. So if you have missed, no issues, but keep update the feedback then and there and complete it. And also please give your full participation, since everything has been grasped through online. The attendance will be tracked online. So give your maximum participation to claim the e-certificate. And tomorrow morning we have a session from an industrial sector perspective, and also with another person from industry. Morning we have Heratech Private Limited, Mr. Vijay Bhaskar, CEO. He is going to deliver the lecture, and after Mr. Manigandan from Geonlogics is going to deliver. And we have one demo of colon cancer prediction using Google Colab tool. So really it is one of the impressive thing tomorrow we have. And followed by tomorrow afternoon 3:30, we will be having an assessment for 25 marks. that will be posted here, and you can utilize it and give your best in the assessment, and also based on this assessment feedback and everything, we will provide the certificates. Thank you. Thanks for connecting. Thanks a lot.